Hello, folks. Hi. Don't know who's online right now. Ooh, a small moose and mindfucked. I guess that's how you pronounce your username. Thanks for the follow. All right, let's get started, shall we? Hello, everyone. How's it going? Good to see y'all. Um, I want to do a Pooji control, and I think there you go. I need to bump that up a little bit, maybe to 61. We have tweeted. We have waited. Yeah, I be cooking. Get this. So a friend is setting up this massive sort of computer, right? Like a 128 core, something like that. So I sent him the Atacama and the Riot repo to run the benchmarks there, and he's just texting me back some of the results, and I'm trying to read. It looks pretty amazing, like the bandwidth. Where the hell is it? There's so many tiny numbers. Oh wow! So the Atacama. Let's actually start with something else, right? Where is it? Bandwidth per channel. So the AIO version, which clearly can be better, can be much better. Oh, the camera is doing this weird thing. All right, whatever. Um, the AIO version, right, is running at like 230 Mbps, the bandwidth, and I think it can be made better. I just I'm not an EIO expert. Then we have the Go version, which is running at like 3.4 gigabytes per second GBps. Pretty insane. The Rust version is also around the same, and this is something that I think a Rust station that knows how to do like you know stream network programming there should have a look. So, all right, so we have like roughly 4 gigabytes, 4 gigs on Go on Rust. EIO is way lower than that, right? At 0.2 gigs, and then Atacama is not doing so bad itself, right? At let's see if I read the number right. Yeah, around 1 gigabit per second or gigabyte per second. And that actually tracks with what I was seeing in some of the file tests. Like when I was working with the IO reader and writer yesterday and the day before, we had this massive 1 gig buffer that we wanted to write into DevNull, and writing to DevNull is so fast. It was like nanoseconds. That can be right, but when you write it to a file, then it was mostly like a second to write a gigabyte down. Um, yeah, so interesting to see this stuff. 428 it seems that as it is right now, and again, I need someone that knows how to do EIO, right, to rewrite that benchmark. But right now, it seems like we're 5 times better, uh, and roughly a fourth of the speed of Rust, which I'm, you know, super okay with. I mean, we're barely getting started here. Oh, we got 7 here as well. Amazing. All right, so where's the thing? Here's the tweet chat. Where's the chat? Primage and blazingly fast numbers. Go, go, go. Share with the fam. All right. So for this stream today, I actually just started a repo, and because clearly I am the best at naming things, I'm calling it Chatty. Come on, it's a pretty good name for a TTY chat, right? Just tell me it's not, or give me a better name. I dare you. I dare you to give me a better name than that, than Chatty. And we'll start from start from zero. So repo. We have a repo here, right? Do I actually like to do this from the outside? Init project Chatty, right? I need to eval that. I hope it did the right thing though. Let's see, Chatty. Yeah, seems like it did. Um, Chatia. Oh, like Chatio. Chatio. Chateau. Is that how you say chateau? Chatiao. A large French house or castle. Chateau. Yeah, great. Chateau. Yeah, cool. Very, very important detail. Every now and then I'm gonna check in here. No, look at all my domains. I'm gonna check what? I'll just go back. There you go. Refresh and see if the OCaml AI domain is configured correctly. I'm sort of checking on Cloudflare to do the DNS thing, but all right. So we have that there. That's the repo. This is the code on the left. I think you don't really see the repo. Time for glasses. I think, Tom, I need some glasses. Thank you, by the way, Tom, for the donation. It was great. It has helped us get the domain, camel.io. Okay, oh, shit, I forgot to open the stream stats here. Where are the stream stats? Come on, stats. Do your thing. Twitch. There you go. Connecting the phone. Going to live. Going to stream manager. Cool. Hiding all of the stream stats. Just want to see events in chat. Activity feed in chat. Perfect. All right. So first things first. I wish, right? Minty, like that. Blink. Nope, that doesn't work yet. One day it will, but not today. So we're just gonna add them to our project. We have all this stuff. Fine. So I'll just copy the Doom project from somewhere else. It's a lot of things here, but it's okay. And we'll replace Minty for Chatty. And it's unlikely we're going to publish this right now, so I'll just keep this empty. And we'll remove all of that. And right now we don't need any tags. We do need Riot, and we'll go for 7 and above. And we don't need TTY directly, but we would need Minty, right? And the last version is 1, but we have 2 in the books, right? Here, the current latest version in the repo that just got some updates by Tom, who's in chat. Everybody, how do we do this? We want to do a shout out. Shout out to Lesp_, for being OCaml. I'm going to follow you there as well. OCaml pilled and contributing an amazing component here. Where the hell is it? Closed. Text input. Did you know we can do this now? Look at that. Worst demo possible from my end, just to zoom into the video instead of going full screen. But you get the point. And we're gonna need a blink. Actually, no. So we want to first opam pin miti 002. So we have that available. And then we go, yeah, just rebuild everything. I don't care. What is this? 11, 10 minties here. This is chatty. And we also want Blink because we want to make some HTTP requests, right? And right now we just have one here, which is okay. And Blink depends on the CA store, so we don't need it ourselves. Cool. So that means we should be able to do build. So we'll do it here, right? And we'll get started. So lib chatty ML. That will be our library, right? And then in bean main, here we will use we will build a TUI. So I'm thinking first we're gonna start by picking a chat API, like for example the Twitch chat API, and see if we can get some of the chat messages here on screen, right? And also write back. Starting a poll. We don't want all these things right now. We just want the basics. Come on, just let me. There you go. Chat and chatbots. Ooh. No way, seriously. They have an IRC service. Normal message flow. Okay, let's go through getting started and see what they do here. They use TMI for the chat. So we need an identity file, which I will write off screen. I'm definitely gonna accidentally leak this. I already know it's gonna happen. And then the chats. Thanks for the follow, Reynaldo. Reynaldo. Or with the R's that I use, Reynaldo. So we do a client and we just have some handlers for messages. This sounds reasonable to me, like the high level API, right? You want to sort of build something that will respond to messages as they happen. All right, so let's go to our chatty file, right? Nope, I want to, what? Test chatty, is this new? No, did we pick the test underscore instead of the underscore test convention? Is it going to be test this and test that instead of chatty test ML? Like every other programming language out there? Why do we do this? It's like we want to be alone. Like we want people making fun of us. Okay, so what am I doing? I'm just fumbling here. Leave chatty ML. Cool. Now that we have the file, we will have some Twitch module here, right? And this will likely be module chat. But it should be more like all the languages. We are already great at so many things, right? We don't need to be unique in every possible way. We just need to be productive and just use the strengths we already have. Honestly, if we did that, we would wipe the floor with Go, for example. It would just happen. I don't make the rules, sorry. So we have some options and stuff like that. And then we connect the client. Okay. So my guess is that there's a client that we need to create. And that client will have sort of information about who we are and so on. Config. Actually, we might just have a config then. What do we need here? We need the channels, we need the identity, we need the options. Don't need to be too smart about this. Identity, we don't have inline records, do we? No, we don't. Makes opportunity there. Identity. And also we don't have record punning. Oops, sorry, I forgot to do a touch OCaml format. I think that should help us format the file, right, when we read it or when we save it. Good. I don't know. I just assumed that. I don't know, honestly. So when we want to make a client, we'll have a type T here, and we'll do make, and we'll pass in a config, right? And right now we'll just save the config here. So config.t. We don't need to do much right now. So config. And it looks like the API is not really versioned or anything, but that's fine. So I'm not a fan of having all of these different events at the top level of the client. I think having a chat subset of things will be okay. But then again, maybe we want to structure this so that you create a client, right? And then you just like hook on all these different events, like type event, right? And we have a message connected, right? So using the client will be more like Twitch make, or client make, right? And we'll pass in a config. Let's say this will be a function called run, right? And we'll have a Twitch variable here, right? And what do we expect? To be able to do like Twitch what? On, message, and then we pass a function. So if we want to do that, then I think it would make sense for this thing, right, to be a get. So we can encode the return type, right? So when you do message, you get a message handler. Whatever it is that happens here, we'll get like a message list event, right? Like that. So then we can make this on function, right? Recognize the return type of this variant as message list, and then this will be here, will be of type message list, which would be super nice to use. But we're also on Riot right now, and if we want to receive messages, you can literally make those messages, right? So I think the client should be a single process, right? So here we would do like Twitch on, and then we pass the Twitch instance, the message, right? And then the handler. Something like that. We can get rid of the client here as its own thing. We will have an identity, and then this will be a config. Okay, simplify things. I like that so far, right? So we can grab all the things and be like connected, and then we will put the handler for a connected event, right? Yeah, we can 100% do that. The question would be like, do we want to configure the client like that and then do something like Twitch start link, right? Because then we will start a process that does this thing for us. And that one will have grabbed all the different handlers for the different messages and just run them for us, right? I think the GAT is like, this is a very basic usage of GATs. Like there's no existentials or anything. We don't have to do that, right? So okay, let's fold this into draft one, right? Like that. If we do another draft of this, which I think I'm gonna like better, right? We want to receive messages, right? Like Riot messages. So we will have type message T, right? And here we would add more things. And this would be like message, right? And it connected. I'm gonna open Riot up top. Leia now. Okay, just there we go. Was looking for the water. So now that we have the message there, then we can just add those variants. And we will want a function to spin up, right? A process that is Twitch, right? Or like a connection to Twitch. So this will take some config, and then we'll just spawn it, right? And we'll do init, right, with the config. And we'll just return okay with PID. Now, Leia, no pode. There we go. And we need to give libraries to this thing, otherwise you won't know what to do. We want so far Riot, but we know we're gonna want Blink as well, right? And oh, sorry, I need to actually do an opampim on Blink. Opampin Blink 0, like that. No, it's Portuguese. She's from Rio. Cool. So that worked. So if we work this way, right, we will need an initialization function that will do something for us, right? And we here probably want to create a connection. But this is going a little lower. So we will want to connect. And here I think we're going to use Blink, right? Connect. So we can have a config. And this will have like a URL to Twitch. So we can do connect, and we get config.uri, right? And right now we really don't care, so we can just get an okay there. So if this dies, this process will die, that's okay. But if it does not, then we'll get a connection, which is great. So now we can go into loop, right? With our actually, we might even want to do this earlier, because we already have a result here, right? Okay, PID. So we can probably just try to connect, and if we can't connect, we won't even start. So we'll do state. It's gonna be config and connection. Con. Now Leia, what do you want? So we'll have a config and a connection, which is going to be a blink connection T, right? So we get some state, and we can do some initialization here. Okay, I need to regroup. All right, you okay there, Leah? Let's just make some space. I'm gonna move the camera a little to the back. Okie doke. And oh yeah, we're just missing this, and we're gonna be using this one a lot. But honestly, one thing I love about using algebraic effects is that normally this is gonna be a result. There's no promises or anything or other big, messy, fussy monads to worry about. It's just results. Cool. So we have connected. How do we initialize? Do we need to do anything special? This is just using the I guess we don't need to do anything, right? We could just go straight into looping. I think I would like to use the Twitch API directly. Twitch, just show me the damn API. Where is it? This is an example with a library. I don't want to use your pesky library. Authenticating with the server. Okay. Does this work over WebSockets? If it does, we're screwed. We have an HTTP client. We're gonna need to make a WebSocket client. All right, 50-50 chat, 50-50. This goes south, and we need to make a WebSockets client before we make the chatty. But hey, I love me some use case driven development, right? Send and receive messages. This socket, WebSocket. I am not seeing endpoints, so I'm gonna assume that this is actually all working over WebSockets. Yeah, using WebSocket or a TCP. Okay, TCP connections. We have those. Oh, this would be cool because we can make the Twitch client actually just use a TCP connection, right? And I think I wonder if we can use Atacama for this the other way around. Because right now Atacama is so you listen on a socket, right? And then you have a pool of connections. Maybe we want to do the opposite. No, we want to do the exact same thing. No, we want just one socket. And then messages come through from that socket and we just read it. Okay, not all is lost, but we might need to implement the API at this level. We can swap it out for WebSockets if we make a WebSocket client one day. Example chatbot. So this is WebSockets. So how do we open a TCP socket and authenticate them? Authenticating. So we need to do a pass and a nick names. But I don't want to do bots, so I just want to, let's see, sending pass a nick. The token. So what is the endpoint do we connect to? After registering your bot, can't I log in with my an OAuth token for myself? Hey Ant, how's it going? All right, let's check. So Twitch TCP chat. We have a URL there. Let's see if we can telnet our way there. That should fail, but oh, this is the no. We don't want the WebSocket one. Maybe we want IRC. Twitch IRC protocol. Is it Twitch TMI 421? There we go. That's the stuff. So WebSocket and IRC. IRC is kind of the same. Let's go with non-SSL one right now. 6667, right? And that didn't work because we probably want to get rid of that. Cool. It's gonna be impossible to try this on camera, right? But at least let's see if it breaks. Hello, unknown command. Okay, so I have Nick improperly formatted. That's perfect. All right. Oh, they closed the connection. Damn. We can send ping messages as well. Ping pong. Can we do join bar? No, this might break. Supported IRC messages. Nick notice. Pass. Damn. Did not like that. New river. Nick. Right. So maybe we need to send pass with the format they had here. Where was it? OAuth. Getting started. Pass. Authenticating with the server. Pass. Sending pass ending messages. Like that, right? So that's obviously not going to work, but there we go. So that's the format. Okay, we can do that, right? So when we open a socket, we actually don't need to do blink. So this is sad because we really thought we were going to need HTTP support, and now we don't. The amount of crap that we built thinking that we're going to need it. Obviously, having an HTTP client is great. Obviously, the improvements of the IO are great. Yeah, first I blinked, then we got robbed. Have you ever had the situation that you can't listen to a former Fab song? Jackson, is it Michael Jackson? R. Kelly? Yeah, I haven't listened to Michael Jackson voluntarily in ages. Then again, I don't listen to Ozzy Osbourne either. Not because of anything they did. If they did something, I don't know about it. Just I don't like how he sings. All right, screw it. Net socket, right? We're going in, folks. We get a socket. Perfect. But to do that, we actually need a stream address. We don't do URIs, so we need to do. Oh my god. Address is gonna be net socket. Net address, right? Of URI, which is good. But unfortunately, this is an option, so we're gonna have to do an option to result, and when we have none, we will just say bad URI config URI, or by config really. No, but bad URI is good. Config.uri. So now we can do star over here, right? And we get one of those. I am gonna ask the formatter to do something less terrible for us. Hopefully, it will comply. Okay, it did not. It hates us. Hates us. Oh, I said URL, not URI. Okay. URI, URI, URL, URL, URL. Cool. So now we connect, and we get a stream socket back, and we can say both the connection and the address. So now this is going to be a net socket, and this is a stream socket, which means we cannot listen to it, we cannot accept connections on it, but we can read from it, right, and write. Address is going to be net socket address, and I think we need a stream address as well. Cool. So connect. Oh, sorry. This is address like that. So when we do start link, then we actually will try to first get everything in place. Because if we cannot get these two things in place, then we just cannot, right, get the chat connection started. Mood change. Okay. So this process, when it initializes, it needs to do the login, essentially passnick. Or we're gonna do login here, right? I don't think we're gonna get credentials out of this thing. We might need to do requirements. So let's go into the config and say whoever you are, we need an auth token, right? Or actually just a pass. We need a nick, and we need a cap rec. This will make sense if we know about the API itself. So I think that's fine for now. So maybe we want to call init here, and init we will do this. We will check that we have the address, check that we can connect, check the requirements, and then do a login, right? If we got all those things together, then that this process should live, make sense for it to live. But that all of a sudden sounds like something that should be happening inside of the process rather than outside. So we will put it together a state once we have that. But before that, it's not relevant. So we initialize and we get the address. If we don't, then we will blow up, right? State, here we get a config. There you go. We get a connection, and then we want to get the credentials. We don't really want to get the credentials. We want to validate the the requirements first, and then do the login. So validate requirements, right? And we'll do config caprec, and then authenticate config. I think we can just pass in the config, it's fine. And then if those two things are good, then we will loop. But we actually want the loop to not have to deal with that result value. At the end of the day, processes are unit to unit, right? So we need to deal with that resulting value here. And note to self, turn this into a supervisor. So if for any reason the connection breaks, right, we just retry. Not forever, just a couple of times, but it would be good to have that there. Right now, one process is fine. So we'll just do result get here. Cool. So let's do that. Validate requirements, right? To do that, we actually would need the connection. Same for authenticating. Connection, and then we have the requirements. And we can quickly check if the requirements are empty, right? Then we'll return an error, invalid. Must have requirements. Or no, yeah, okay, that's fine. If we do have requirements though, actually we can probably do an if here. If we do have requirements, then we want to write to this socket, right? So we'll do net socket send, and we just need to put some data there. And this will return a nice little result that we will ignore because we don't want to leak that. So we just do okay here like that. And when we want to do data, we'll do IO buffer of string, right? And we're just gonna put caprec, right? Like that. And then we'll do rex. It's gonna be caprec, string, concat, right? And I think they're split by, yeah, spaces. Cool. So far, so good. Makes sense. What do you want, Leia? Want to be cozy here? Be cozy. I approve. Now we want to do the authentication. Wait, I don't really know what the value out of it is. Connection, and then we have config here. So that will be close. We're gonna make a helper function here because we need to do the same thing again. And we'll need to send several things over the socket, right? So we'll do send, right? Connection data. We need that thing. Oh, that's already there. That's fine. Whatever you send us as a string, we're going to put it in data here in a buffer, right? And then we'll send that. So you can just say send, right? Connection. But I don't like that we're calling send because we have send also in Riot, right? So send here, it's a function for sending messages to processes. So maybe we'll call this what should we call it? Ooh, command. I like that. We send a command, right? To the biggity beep. Cool. So we need to send another one here. We'll send pass, right? And that will be pass space, and we'll do config pass, right? And here we'll do and then Nick, and then this would be Nick. So commands. Match commands with empty. Do okay, else we'll grab a command, right? And just do that. Turn into a buffer. Push the buffer. And then we're gonna recurse. Recursion for the win. So that should make it rather easy to say like command. I want to run these commands 1, 2, 3, 4, right? Cool. So authenticate does that. This does the other thing. And if we go through those correctly, right? Okay. Maybe one last thing, right? I kind of want to be able to do that. Anyways, that's a small detail. Now we have a state. We can go into looping, right? And here looping is where the nice stuff happens. So we would definitely want to set a buffer internally, right? In the state, the receive buffer, IO buffer T. And this is the thing where we're going to read from, right? One message at a time. In our loop, right? We would want to, after we send that, we need to actually read messages from that socket to know what the hell's happening. You know what? We're going to test that command here in the Telnet chatbot and see what happens if we do that. Ooh, look at that. So this is the response format that we're going to need to parse, which is fine. So let's do just that, right? Network, socket, and we want to do receive, right? And we're going to pass in the buffer from the state. Buff, state. And then we also want to pass the connection. Oops. And this is going to tell us how much we've actually read, right, from that buffer, which is important because the buffer may be much larger than the message that we want to read, that we just received, right? So if we have an OK, we have bytes, and then we'll have response, and this is actually going to be IO buffer sub, right, of length bytes. So usually we call this length, and then that will be buff. Now this thing, right, if you go sub, right, with length and buffer, it's a buffer as well, but it hasn't really copied anything. It's just a subset, like a view into the same data, which is kind of nice because we can parse just that if we want, right, and we don't have to touch the entire buffer. Cool. So now that we have that, we want to parse that response, right? So we'll do parse response, and we will get a response back. Okay, so one small problem here is that these functions, right, are only writing, but they're not really reading back. So we'll be writing all these three things very quickly, whereas we probably want to send one, wait for a reply, right, and then do that loop, which means command most likely wants to send all of the things you're telling it to do, and then sit and wait, right, and parse, like wait until we have collected all the responses, and parse the responses into some data. So when we say validate requirements, then we send cabrec, right, and then it waits for TUI to reply and say, oh yeah, the requirements are these ones. Acknowledge, we're good, right? And then in validated requirements, we can do something with that. We can say like reply, for example, right? If the reply is going to be, for lack of a better naming, capac, for example, right? And then we have rex. Then here we can check if the requirements are the same as we have, right? Then we're good. So I imagine that if we send bad requirements, right, like something like that, then we will have knack for some things and ack for some things. Okay, that's good. So we might get replies from that command, multiple. Which means we can no longer nicely pattern match here for ABC because we don't know how many requirements people are passing in, right? That is something I miss from Erlang and Elixir, especially Elixir. The ability to build up a pattern match dynamically, right? And then say, match some value with this pattern. So here we'll need check acts or check replies. So if we have an act here, then we'll just go forward and do check all act replies, right? And then we have a capnac requirement. Then we'll return an error saying unmet requirement, right? And if we're done, then we'll be like, okay, we're good. So we can do check OLAC. Perfect. Now we just need to define the variant. Let me hide this thing here. Cool. What do you want to do? Do you want to stay? Wait. There you go. Cool. So, all right, off you go. I think we're gonna build, just make a variant, right? Commands, caprec of string list, pass of string. Come on, tell me it doesn't make sense to use a get here to know exactly what type of reply we'll get. I know, right? So cute. Pass, and then we get a nick of string, right? Screw you guys. I am making a get. Because it makes sense. Here it makes sense. Got him. Got him. This might be a terrible decision. We'll see. So what is the response from pass? So there is no one response from pass. You need to do pass and then nick. Okay, let's remove the get for a second. We'll do reply here. We know that we have an authentication, a login authentication failed. But that's just a notice. Is that really the... I'm going to actually copy this. They had an example here, right? Pass auth like that. Then nick. And then capback is this one. And then capnac is this one. Notice of string? That sounds weird. We could probably pattern match a little more here, right? And just maybe do a login failed. But we don't need a... We can do it off here. What is happening? Why do you break the lines like this? Why not this? Okay, you know what? I'm not gonna fight with you, formatter. Do your thing. Do not care. Cool. So we essentially need to check that everything we have is a capnac or a capac. And the problem with not using the GAT is that we will need to ignore, right? All the replies that are not one of those two. Caio Imperial, tudo bem, mano? So if you give me a command, then I'll do data equals command to string, right? And yeah, we'll just do command here, match command with caprec, right? And this is gonna be caprec, and we're gonna do, nope, we're gonna do that one. Where are you? 6, 6. There you go. String concat space rex. And if we do pass, and then the pass. And then we do nick. Cool. So that way this function now grabs list of commands and now returns a unit, but we needed to make it return list of responses. Oh yeah, also this will be like that. Ooh, much nicer, isn't it? So I think we will need to read until we get a new line. So I'm just gonna go into a loop here. Once we've sent all the commands we need to send, right? We're gonna say read responses connection. And we want to do a net socket receive, right? And we actually will need, okay, so I think I'm just gonna thread the state around. So we can always do state connection, right? That will be our buffer. We can go back to command. We can go back to send response, right? And now we can say receive. And I want you to receive into the same buffer, right? Here. Since we're gonna need to, I think we're gonna need to loop, but maybe not in the top level. So buff, and we have a connection, right? So again, match, and we'll do OK, and we get the length of the bytes that we read, and we're gonna copy the bytes out. And if you're like, oh, Leandro, this sounds like so tedious, Why do you have to do all these things over and over? Like, folks, this is a very low level API sockets. Like, we're like going all the way down to TCP. This is just sockets. We have not built any conveniences for this. We have built conveniences for HTTP with Blink, where we have connect, request, and stream, and it's gorgeous and it's so nice to use. But unfortunately, not what we need to use now. Leia, where are you? Okay, she's gone. And I imagine you saying these things because I am saying those things. So I'm mostly answering myself. Leandro, why are we writing this thing over and over again? It's like, okay, this is just the low level version, right, of how it should work. Like, we want these pieces here so that people can build abstractions, but also so people can build different kinds of flows. Sometimes you just need a single receive, and sometimes you need to receive in a loop, right? Sometimes you need to use the same buffer, and sometimes you can throw away the buffer or need to throw away the buffer, right? Because it's not yours. Somebody passes in the buffer in. Stuff like that, right? So we just don't, it's not like we're over engineering, we're just not making assumptions at that layer, right? Over engineering at this layer would be like, oh, we have a function for like read until new line, right? Or stuff like that. Because we're trying to come up with what are the use cases that you're going to have. But instead we go like, well, we don't know what they are. That's fine. Sometimes you do know though. And when you do know, then not having that read new line function is like, come on. Pain, yes. Hey, the useful distraction. This was a useful distraction. Thanks for the follow. All right, so we get a raw response here, or we get some, yeah. And we will want to turn that into a string. So I actually think when we do to string, no, that uses the fully, I think we made this use the fully filled string. So if we go into IOML, buffer, to string, yeah. Yeah, that's good. So we can do to string, right? And that will give us the raw string of whatever we just wrote into the buffer, assuming that the buffer fit the entire command, right? Then that will be that. So we're gonna, assumption number one, we're gonna assume, note, this function assumes the buffer is large enough for any command any response will ever get. Big assumption, right? But if it is, then we get a raw, and then we can do parts. It's gonna be raw or the string split on char. We'll split a new line, right? And then we can do commands. It's gonna be, or I guess like parse. Parse commands, parts. If it's all good, if we parse all the commands okay, right? Parts with an okay. Else we get one of those. So we'll do parts, and we can do parse commands, parse command of string maybe, and then parse commands, parts. No, we actually need to use the operator, and we would like this to be tail recursive because that's always nice. So we'll put an ACK here. And we'll do parse commands, and we'll do command ACK. Cool. And then command of string will be just one of those. So that will be, this is the easy one, right? If, easy. We can do string split on char like that. So we will have the first part will always be TMI Twitch TV, right? And then we want to check for if we get cap, right? And we get a star. And we get NAC. Then the rest is going to be requirements. So we do cap NAC rex, right? If we do AC, then we get cap AC. We could probably ignore this first parameter here. And then if we get notice, like we did, where is it? Here. Ooh. Then we get a login. And then we get a message. And I don't know what this is yet. But my guess is that we're going to have more notices. So let's say kind message. And these will all be OKs, right? Else, anything else is like could parse error. That's what we know right now. Let's go into notice. Notice is going to be a string of string. And let's say kind and message. Wow, this is a. Oh, you know what the problem is? Is that I think this is expecting this to be dog strings like that. There you go. That's a problem. If I do that, perfect. That makes more sense. All right, cool. So let's move that over there. Leia, what are you doing? And now we can turn this into a tiny, cute little record. Woo. We will have maybe more words. So we just put that there. Okay. Now we just need to recurse because we have not. And now response. Cool. We don't need to use length. And in fact, because read responses doesn't care about the errors, we can legit just do this. I'm gonna read, and we'll do that. And this will be receive buff. Ah, so nice, isn't it? Read responses, gets a state, and it will try to read a reply list, right? Or error read like bad response, connection error, whatnot. But the important thing is that this will actually block, right? So the current process will pause here until we receive enough data. Or like one frame, I think one frame finishes. We'll see how this works. I expect that maybe this will not do the thing we think it should. 1 second. The cat is doing something. I need to go check on her. And we're back. The cat was eating trash. The first in line. I'm on my knees. So we'll do the same thing here, except that no, actually, the loop is not really that anymore, right? Leia. Aye, aye. Okay, we've done enough already. We're just gonna do a yield here, so we don't starve the CPU. Doing build. Let's see how far we are. 113. We have a reply list, and of course, because we haven't done the thing that we haven't done this right. What does the successful each message is delimited by RN? Oh no, okay. So this is not like a kind or anything. All of this is just a message. All right, so let's go back there. Is user supposed to be my username? Okay, I'm gonna open a new Kitty terminal. And I'm gonna do something dangerous. I'm gonna put it under my camera. So you don't see it, right? So there. Oh my god, it's so tiny. This is gonna go poorly. If yeah, Leia, this what it is. But I love her. She's great. So there's a terminal here that you can't see. And in that terminal, I'm actually gonna. Now that makes no sense because I need to generate a token so you'll be able to grab it. Whatever. So let me try that for a second off camera. And I'll generate a token. You go Johnny Depp. I'll generate a Twitch OAuth token and I'll see what the output is. I will be right back. I mean, I'm here, but you won't be able to see me. What happens if I remove the main screen? Oh, yeah, I can do that. That is great because now you can still see the chat and everything. Savage. I know, right? Oh, I feel like this is gonna go poorly. This is not gonna end up well. Connections. How do I make some tokens? Settings. I'm in settings. Maybe I need to go to my channel settings. No, that makes no sense. You can expect everybody that needs an OAuth token to be a security and privacy. I'm keeping an eye on what's being streamed right now. Screenshot right. You know I can just disable the token, but how do we do this? How do I create tokens? Oh, I need to go to DevTwitch. Really? That doesn't sound right. No, it does sound right because I will need to first have an app, right, that you can log into, and you log into with the link that you can generate. That's cool because then we will also need to have a little web server. Bruh, you cannot screenshot what's not on screen. Oh, okay. I think this is safe for you to see it for a sec, just for 1 second. All right, chat. Don't misbehave. Don't misbehave. Ready? There we go. So, Twitch board last updated 2018. I was trying to do some exactly the same thing we're doing today. History repeats itself. No, I got leaked. What the hell? No, you can't see the token there. It's fine. Right? Yeah. I'm just panicking. Nix, stop gaslighting me. It is not on. Chad. So I have an application here, right? But this does not have a token for me. Okay, I think I've got I've got the things I need and they're already in the terminal, but you don't get to see them. And if you do, then I'll just remove the application. Whatever. So let me just double check the permissions. What can this thing do? We Why doesn't this let me save? I don't know why I cannot really save like a name change or anything. So I'm gonna register a new application, right? We'll do a local URL here for the Twitch auth callback. Category is gonna be, I guess we could consider this a chatbot. I can't. I cannot create applications. That's weird. Create. No, like right now I'm on the Dev Twitch website trying to create an app there, right? And I press on the save button, like create button, and nothing happens. They have a bug. Undefined enum value. I can show you this. There's literally no secrets on screen or anything right now. Really? I don't know. It could be like I have a URL there for the callback locally, the name, chatty. If I go into the section here, right? And now I get the impression now it's gonna work. So I'm gonna first hide the screen and then try to create. Nope, it did not. Apollo service error. Create OAuth map error. What the hell is this? The response says that there's a service error. Real world type errors. Yeah, 100%. Let me screenshot that. That's good for real world type errors. Whoa, that was loud. So copy that. Save the clipboard. Is it a single world type errors? So we have a comment here from Adam Brodzinski. Kind of went through this sometime. Eventually, will this lead up to being competitive to Elixir Phoenix for multi-core web apps? I have no idea how fast current OCaml Dream is with LWTUEIO, um, but that Erlang VM is pretty nuts. I think we'll always be behind the Erlang VM, but for some specific use cases, we might be able to be faster because we don't have the same overhead in execution of the code itself, right? Like you don't have VM in the same way. Um, I can't speak much for the performance of Dream. What I can tell you is that for the use case of having thousands of processes and stuff like that, we will definitely be better than EIO. And yeah, loot is still limited to a single thread, right? So in that space, we'll be orders of magnitude faster than loot, unless at least that's my expectation, right? So let's see how we can write that. Yep, I expect this to, or actually, I'm not expecting it. I'm working to get there. Um, I would say we want to be or as fast as Erlang, and for some things we will, since we don't have the VM overhead. But for many others, we won't, since they have 30 years of time on us. But loot is still limited to one thread, and EAO isn't optimizing for the kind of concurrency we are. So unless Dream suddenly tries to be process based, I don't think we'll have much to worry about. Of course, the use case of number crunching and isn't. I wouldn't need to do the caveats there. That's fine. I think it's fine. Any other replies here? No. Bunch of follows. Okay, that sucks. But we still have another app already, right? The old one. This one. Mesa. Yeah, I hope the Mesa will be great. We'll see how far we get it. But in the pipeline of things to do is like first we need to make Atacama correct and fast, right? And then goes Nomad, which is HTTP support, right? Like Atacama is just sockets in a pool of sockets. If we have HTTP support, that means we have a correct sort of tiny little layer that does HTTP, HTTP2, WebSockets, that sort of protocols, right? On top of that, we can build things, and I started sketching Trail, which I love how it's looking. It's a super tiny thing, right? You just define a pipeline of functions, and this will feel a lot like Dream in some sense, right? But it's if you ever use Elixir, this is plug, essentially, right? You define your plugs, and they can be whatever you want as long as they're a function from a connection to a connection. Done, right? And this will help us build things through layers, except the Tokyo stack in OCaml. Yeah, I mean it's kind of the same thing that Elixir has that Rust has done, right? As well. On top of this, however, we can build something like Mesa. I don't even have it open here. It's just way too early days. I'm experimenting there with how to structure right the application to minimize things like build times. Because one of the things that people do a lot when they're building these frameworks, let's see if we can go to example app, right? One of the things people do a lot is saying like, oh, I'm gonna put all my controllers together and all my components together and yada yada, right? But then that means if your entire web layer depends on your domain logic, right? If you change one thing here, then you need to rebuild this whole thing, right? And you may have a ton of code here, especially if you're doing like server side rendering, right? A lot of views and components and all sorts of things that you really don't want to build again. So I'm starting to like I've been working in a code base that's written using I can close this crap um, Seal, right? And it's pretty large, like 300,000 lines of OCaml or so, the code base, and it's pretty slow to build things. But when I compared that to OCaml Dune, which is also pretty large, like 400,000 lines, Doom actually builds pretty fast. Yeah, but Dune is able to do magic incrementally as long as your build graph is sane, right? And Seal applications have not got that they don't have a sane build graph. It's fine when you have a tiny project, but once it grows and grows and grows, then Dune can only say like, okay, here's a library, right? Like your app or whatever, right? It changed, so I'm gonna need to go through the dependencies and rebuild those. At the very least, try to type check them again, right? Because you may have changed your types. Um, and in fact, if you treat the library, not the module, right, as a granularity level, then let's go. Cache might be a small one, right? Yeah, but this will be a good example, right? If we change the the repo SQL file, right, then that means this entire library, right, has been caching validated. So if you depended on Seal cache, for unfortunate library to pick, right, then yeah, I think the interface might play a role there, right? If you hide some things with a good interface, then you'll be able to say like, okay, we have not changed anything, right? That has been exposed from here. So at least at a type level, it should be fine. But you should still run tests again. Because if I change the code inside of a library, right, that you depend on, it doesn't matter if the interface is the same, if the types are the same. If I introduce a bug in the behavior, you definitely want to run the. Yeah, I mean, like you need to think about this in any case, right? In any program, in any build system that does incremental things, you need to think about these things. It could be Dune, it could be Bazel, it could be Pants. Take your pick. If you don't have a build system that does this, then you have a shitty build system, which is okay for a lot of people and a lot of use cases, right? It's just inherently going to be slower as you grow. But anyway, so the point of Mesa, I think, would be to first find what is a structure that will let me say I am working with the album sort of sub application. So inside of that sub application, I will have things like my controllers, my models, all of the database data, and so on, right? So if you change something in there, you don't have to rebuild your entire app. You just have to rebuild that section of your app, right? And I think that's important to keep build times fast, keep test times fast as you go along, right? So that's one of the things. There's still the problem of people building like horizontal component libraries, which look so pretty on their own, but they're a fucking horrible idea, right? When it comes to build graphs, unless your component library exports every component as a library, right? Which is inconvenient. It's very inconvenient to use, to consume, but it makes the build graph granular enough so that if you change every camel is horizontal. Yeah, it's yes. But you can imagine how actually I don't know. Let's see. This is not very good examples. I'm trying to find an example that would be good here. All right, we have a couple of things here, right? You can imagine how if these were components in a library, if I change the entity component, right, I would only want to rebuild things that depend on the entity component. up till I've seen your APIs. What do you mean? I think I'm missing something there. Yeah, it's for a lot of things, horizontal is okay. Flat is okay, right? Especially for like frameworks and stuff like that. Because you usually want to send, like, your entire app depends on, let's say, Riot or Dream. If you bump the version of that, right, it's okay. Flat's fine. But for large applications, right, then maybe not so much. What I would love to mess around in Doom with would be to generate the build graph, right, out of two things. One is the folder structuring, so you can say like, okay, here's a folder, that will be a library, right? But also the actual imports between modules, right? So you may have enough granularity to say, oh, I only use the component dot button, right? So that is going to be the input to my build node in the graph, right? In the build graph. That is actually something that we built for Warp build. Warp, right? Well, not really, right? Because you can have everything in a single folder, and then you have one Dune file. This is not a Dune file, but whatever. One Dune file that says like, oh, here's one library, here's another library, and so on and so forth, right? It is really the stanzas that define the build graph. Yeah, it is very convenient to do flat things, right? And just be like, oh, library, and this is the name, and this it just assumes that everything in that folder is sort of a flat thing. Yeah, you're completely right. All right, so that was a detour. What the hell were we doing? Chatty. We were trying to connect to the socket, and we didn't because the OAuth token that we get is just we don't have a token because we need an app to actually do the login flow. Am I sharing my screen? Yeah, I forgot. All right, so then that it probably means that we need to go back a little bit and do this part, getting an access token. Let's see if we can get the Twitch CLI, because that will let us keep that part at least. The pain. Yeah, yeah, I'm very careful. I'm putting that in a file. I'm going to cap that file straight into an export in an env, right? And then I'm going to remove the file. if this ever works. Triggering configuration. What the hell's doing? I don't understand. It blocked everything. Okay, it sounds like we need to do configure first. I need a client ID. All right, so bye bye. There we go. Dev Twitch docs. I'm gonna go to my console here. You can't see anything. That's okay. Manage. We got the client ID, and we got the client secret now. Perfect. So if that's configured, then I'm gonna try to just get the token, and that gave me a token, but it just prints it out. Remember, I did token, and then I piped that into a file, and this thing still printed out the token. So it would not have worked. Uh, Thanks, Tom, for the warning. All right, so now that I have the token, I can I wonder if I call it again, it will give me a different one. I think this is even using standard error. How to pipe standard error to STD out. I forget how to do that. Oh, two into and one. That's the thing. Two into and one. Okay, so we're gonna do a command here, right? And we're gonna do export. First, we're gonna make a lot of room. We're gonna even go into a new terminal, so we don't have any of that in the history. And yeah, we don't have it. Excellent. You don't see that, but it's here, I promise. And then we'll do client export, chatty, Twitch token, right? And then that is going to be a command that we'll run. So I'll run it first and make sure that it's working. And if it is working, then I'll do the same process, right? Because you don't really get to see. Excellent, excellent. Chatty Twitch talk. Excellent. Okay, perfect. So new terminal, and here we should have none of those things. And no, I was incorrect. We do. So we better stick with the current one. It's gonna print a lot of things. Perfect. So you should be lost there. But we do have it. You gotta trust me. And if if it gets leaked, then that's fine. We'll just reset the secret. Are y'all scared too that that'll get leaked? That I will accidentally print it out somewhere? Ads coming clutch. How often do we have ads? I need to configure things. Scared about a jump scare. I don't have a cable to plug to be like, pop, disconnects everything, right? I'm running a laptop, the camera, everything has batteries. 30 minutes. All right. That doesn't sound too bad. So, oh wait, we actually gonna need the client ID. But it feels like the client ID is safe to have around, like on screen, since you can grab that from the URL that will pop up in the browser, right? Do build. All right. One, two, three. Oh no, I leaked it. That's right. Cool. So 1113. We have that there. We will do Twitch, actually config. We probably want to make that the default config anyways. Goofy system. My kind of name. I like that. Thanks for the follow. So we want to do system get imp, right? And we'll do chatty Twitch client ID. And that will be a client ID, which we need to be able to create the. This will blow up. Yeah, that's fine. And client ID. Is that all we need? Don't worry. Those are not. This is just a command to call Twitch, right? And extract the token from there. So nobody would see it, right? That's fine. So wait, what the hell? The config, what's the config? Pass, a URL, a pass, and a cap rec. So URL should be telnet. Okay, I guess we lost the telnet URL. God damn it. TMI Twitch TV. Do y'all remember where it was? Getting started. Fuck, I hate that they're using like, oh, you just use this JavaScript package to do this thing. I don't care. I do not care. I just want to see like the spec of this thing. Like, where are the URLs to connect to? Requesting Twitch capabilities. Joining and receive Twitch UN. Okay, if I remember correctly, it was TMI Twitch TV, and then port was 6667, and then with the cap rec stuff. A message parser. Interesting. Hey, Star Enigma. Thanks for the follow. Connecting to the Twitch. Thank you very much. Eric chat. So when we do URL in the default config, right, we'll have default URL. And that will be IRC and then 6697. Okay, so not so far. URI parse of string. And we also will need okay, so I guess we will have to make a config object, right? We need a username to be able to emit a pass nick command sequence, right? So we would have to have that ahead of time, and we don't. Twitch config. Okay. So client ID, it's going to be the default client ID, right? And then token. I guess right now we want the default token, but we don't always want that. And then URL, it's going to be the default URL, right? And then there's no way that we have a default nickname, so that's just going to be nick there, right? So here we'll do client ID, URL, nick, pass. I think that's all. We don't need to make a function out of that. What else are we missing in the config object? Oh, caprec. And client ID. So caprec. And the capabilities here, where are they? Getting started, authenticating, capabilities, requesting Twitch capabilities. Commands, membership, tags. Looks like these are them. Okay. Default capabilities. It's gonna be commands, and membership and tags. So capabilities is going to be also optional. And we'll just do default capabilities there. Perfect. Capabilities. Cool. We just need to set up the right client ID here. Dupont Messi. Thanks for the follow. Cool. So now we can do config, Twitch config, and nickname. In this case, it's going to be my nickname. I wonder if we should be using a bot instead, so that worst case scenario has very limited impact. This is a bad idea, isn't it, chat? Config. So we can pass in the config there. .114 validate regs. CapRec actually has a capability list, which is pretty good. So we'll just do list map, capability to string, and we can put that there. And I think they all have the same prefix, right? Yeah. So prefix is going to be that. So we'll do prefix commands. Membership will be memberships. And then tags is going to be tags. Yep, membership. Whew, cool. Validate requirements, authenticate. Let's put that aside for a second. We're gonna try to use this config object to do a caprec call and see what happens. Shall we? Start link. And we'll just do waypid Twitch. And we'll actually do start. And the name of this application is going to be chatting. You'll see why that makes sense in a second. Ooh, it built. Okay, so now we can go into our bin, right? And here we'll do Riot start, right? And we'll have a bunch of apps. And we want to start the module Riot Logger. That's an application of its own. But we also want to start chatting. And if we do this, which I think that's the right way of doing it. And oh yeah, no worries. Perfect, perfect. We just need to return that process. So this will become the main process of the application. So what we did here is saying, okay, any module, right, in OCaml, don't they? I thought when we do caprec like that, we have to send everyone with a colon, but maybe just the first one. You're right. Good eye. Thanks for that. So when we do caprec, we will essentially do caprec colon and then all of them. Thanks. So the interface here is that there is something called a Riot application interface. Every module that has a start function and a name function, right, can be used as a Riot application. And a Riot application just needs to return a process, right? So if you look at the interface of the logger, for example, it has a bunch of things, but it will have, if I find it somewhere, a name and a start function. And that is enough for it to be an application. The application interface might change over time. We might have more methods for lifecycle management, like shutdown, for example. But right now, it just means when the runtime starts, it will start these applications in this order. So first goes the logger. Once the logger is up and running, then it will start Chatty and so on and so forth, right? This means that Chatty can rely on logger being up and running. And if an application goes down, right, then it eventually goes down, right? It will shut down all of the other applications, and then the system will shut down. That is the expected behavior. So here, we can count on Chatty being up and running and just being this application, right, that starts a Twitch process. Eventually, we'll make it into a supervisor so that if the connection drops for some reason, then we start one backup without killing the application, right? And we can do things with that. So I think it's fair to say that this draft one is going to go away, since we're already kind of committing to this one over here. But now I'm going to do the reasonable thing, and I'm going to occupy most of the string with the console. And we're going to do a doing exec, being main, x. And first thing we're going to do in Chatty when we start the application is we're going to set the logger to log level, right? And we're going to put this in debug. I think you should have a bunch of logs. Ooh, we don't see any. How come? Logger info, starting Chatty. If we wait even further, starting Twitch connection. Let's see if we set down the runtime logger. This should not be. Oh yeah, it is private. God damn it. What's happening here? Why can't we see our messages? Is the logger failing to start? Let's do something ugly. Okay, so those messages look okay. Small problem with the logger. Logger ML, why are you not starting? Just recover that. Start. So maybe I broke this. App test. No. Interesting. So the logger is definitely not doing what I thought it was going to do. Logger app. We got start here, right? For it to get started. We call the supervisor. Application test. Oh. Set log level, some debug. Okay, so that it does work. Then why are we failing to do this in Chatty? Okay. It's there, it's working. If we do debug, there's nothing to debug. That's just a problem. Okay, so when we do command, right, we are going to write out here, right, logger debug twitch command, right? Or data. So this is what we're sending, right? Or Chatty. And then when we receive things, we get responses, right? We can print them all. We can print them here. Like that. Part. But I don't think we're getting anything. I wonder if we're forgetting to send the new line. Maybe that's the problem. Yep, we're missing a new line there. So command, when we do off string, we definitely want to add a new line there. Is that not working? Why is the new line not part? Oh, sorry. It should be here. So then we will be able to see it. Cab wreck. That looks like the messages they send, right? Fever. Got to go off screen for a second. Cool. Okay, so this is not cutting it. It is, I mean, it doesn't even work on Telnet. What are we doing wrong and what were we doing right before? Tragedy. Cab wreck. Eric chat. Eric chat. Oh, 6667. There you go. So the problem is that the default URL is actually going through SSL. And we don't have right now. There you go. That makes more sense, doesn't it? Boom, look at that. We got a response back. The response was that yes, all these requirements are act. We have an R there that we need to parse out. The answer is why not OCaml? So it's a functional language, which works very well with how I think, and it's a type language, which also works well with how I think. It's crazy fast. It's like 50% the speed of C. Has a GC optimized for speed, which is great. Usually the programs are very tiny as well, so they're very easy to move around, like kind of like Go, really. You just build a binary and you just like ship it somewhere. It does have a small community and ecosystem, but that means that the OCaml family is like pretty tight, and we know each other, right? And we collaborate a lot, which is nice. Yeah, these are some of the reasons. If your brain works well with typed languages and functional programming, right? But you're also very pragmatic. Like you don't want to solve a lot of puzzle level, like you know, type puzzles really. Like then OCaml will feel very nice, right? Because usually the types are there in OCaml to help you get stuff done, make sure something is correct, right? But to a certain degree, it's like we don't do a lot of type level stuff. We like to stay pragmatic, like it's not a pure functional programming language, for example. Like here, we're writing a Twitch client. for the chat, and we're working directly with sockets. There's no monads for wrapping the sockets or stuff like that. Oh, thanks for the follow, Alexander. The issue with I don't Nix, I don't think we had an issue with capabilities. It was a problem with the port. We were using the SSL port, and we don't have right now um, at the socket level in Riot. We don't have SSL support. We have that code written in Blink. We just need to move it somewhere else so we can reuse it. It would not be that hard to reuse, to be honest. Like, all of this sort of comes as is. The only thing we need to do is sort of wrap our socket in a TLS Unix reader writer. And then we can use the reader and writer to read from the socket and write to the socket, right? That's a good command to have. I don't have it set up just yet, but you can check my dot files here. They're pretty basic. I don't do a lot of crazy things, right? Mostly, the biggest tool I have is the symlink script that I love. I've been using this script in one way or another for years now. Right? Recently, a friend convinced me to try Nix Flakes for installing things, but I only use it for like programs. I don't use it for config. I have all of my dot files in a home folder, because then I can literally symlink these folders straight into my home, right? And in my config, I just have everything in the place where the tool would expect it. So SSH config, right? This stuff is literally in home.config SSH. So it's pretty easy to just move to a machine or modify and copy back and forth. It's pretty boring in that sense. But here it is. I also use Tmux and NeoVim, and I'm running Kitty on a Mac. Have been using Tmux and Vim for ages, over a decade now, and NeoVim recently, maybe a year and a half. Now that I think of this, Nix Flakes, it would be trivial. It would be so trivial, right? Because right now we're using the socket read and write. If we wrap the socket into a reader and writer, then we just literally pipe it through the TLS Unix, and we get SSL. But all right, we just stay on the mission. Remind me later to do that. You know what the problem is with Nix? Nix is fucking terrible. It is the best thing we have for doing what it does, but it's fucking horrible. Language is weird. It breaks all the time. It's so hard to get it right once you get it, you don't want to touch it. It is still the best thing we have. It is the best thing we have, but it's pretty terrible. Isn't there a button for clip that? Woo! We can clip. That's pretty nice. Clipping things. Ooh, Paul. Let's see. Do you like Nix? No. No. What? No. Lol. There you go. Go at it, chat. Let me know what you think. It is hard to back, yeah. At War Build, we took a big page from the Nix book, right, and how we built some of this system. Kind of sad that we don't have it anymore, and we didn't publish like talks or anything. I mean, we did, but we don't have the domain anymore. It was expensive. Yeah, but what Warp was doing that was a lot like Nix is that imagine if Dune behaved like Nix and it generated the build graph from the source code, right? And also managed system dependencies. So like in here, if we did something like X509, right, like create SSL whatever, right, then Warp would analyze the code, realize this module is a dependency of Chatty. This module, right, depends on, I don't know, OCaml TLS, which depends on OpenSSL, right, which depends on some version of libc, right? And then we would install all of these things for you. Yeah, it was crazy, man. Hey, Udu, how's it going? Good to see you around. And then we will relocate and build everything from source in the right place. So in the Warp store, and this will look familiar. I don't have it anymore, I think. Yeah, it's probably empty, yeah. We will have like hash, right? libc, and then that will be the code, right? This probably got downloaded straight off somebody, like the shared cache. And then we would do the same thing for OpenSSL for the exact same version and so on, right? OCaml TLS. I mean, it wasn't exactly like this, but it gives you an idea. So we did that, right? And it actually, I mean, it works. I mean, I don't know if it would work if I just try it right now, right? But that's what we did. And it was such a beautiful experience. But believe it or not, nobody wanted to buy this. Nobody. It is a fucking dream. I know. Yeah, this is what I was trying to tell. But people were like, whoa, it's so far. Why don't you look at Nix? I'm like, no. Well, I feel like I missed out as well because I would love to have Warp to build things. Okay, so that was pretty good. The received responses does what we actually want, right? We get back these responses from Twitch, right? And I feel like I don't really like having horizontal like splits like that. But since we're gonna be sending a lot of long messages, then this may make sense. So one thing that we need to do, probably want to do, is not just split by split. Yeah, we want to do RN like that. Oh. This is the pattern. And then this is width. A little better. We're breaking somewhere in the middle, but at least the command goes back and forth. I'm not afraid of the dark. And if we do a camel run param B, then we get our little stack traces here. Notice how the program is still running, right? Even though the process crashed. Because if we had a supervisor, then we'd just try again. So logger chatty coming back. What is the problem? Right, in here, we can just do a match. And if we have an okay, that's okay. If we have an error, however, then we would want to print out these things. Oof, quite a few errors, right? Bad URI, logger error. Actually, we can probably do this way. Print error, or yeah, print error. And then just do like print error. And then we'll just do error here and destruct here. And of course it does not let me. So match error with, right? And we'll do closed. Oh, we have it here. All right, so I'll just copy that. It's not ideal. Not afraid of the dark. So we'll get a URI and we'll say logger error. Bad URI, right? And then we'll do URI, pp, URI. Cool, and then we get close. We'll do the same. Actually, let me just add to everybody. Connection closed. And must have requirements. We need to provide requirements, or no requirements found. Parse error, error parsing command, and we're going to include the raw error there. So parse error is going to have a raw. Let's go back to parse error, and we'll say part. Timeout. Connection timed out. And then Unix error, we'll say Unix error, and we'll just call Unix error message on that error, like that. And then unmet requirement list, we will say could not meet requirements, right? And then we'll just put that in a list. So we'll do a string concat, right? Rix. And we save. Leia, what are you doing? So line 135. What don't you like? Bam, bam. Oh, missing parentheses there. Leia. Now this would be an A. And this would be error. I don't understand why it doesn't like what we're doing. Are we missing a parenthesis or something somewhere? 135, unexpected parentheses. Oh, there. There we go. Cool. So we got a command that was empty, and that makes sense because that's the last one over there. So parse error, we're going to go a command of string. And when we do parse commands, that's going to come from here. Right, so we get one last new line. Replace all spring and char, string, filter, list filter. Empty. The other way around. Why are you doing this? No, Leia. Where's the thing? Watch out. Oh yeah, I accidentally pressed Q for a lot of things because I have Tmax right with my meta key instead of being Control B, it's Control Q. Um, Ooh, let's see the poll. I cannot see the results of the poll. I have to put them on screen. Current poll. What? The current poll is not there? No, there's no poll. Okay. View results. Haha, lol. No, what? No. I don't get it. This is literally the browser URL we have here. Right? Look at that. Refresh browser. Do I need to remove the cache? Shame, beep, 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 shame. Cool. I gotta say, having written TCP protocols on Erlang, this feels very nice as well. We can make it even better, right? I think we can build something like GenTCP in the future, where you start sort of a link and you say like my callback module, right, or my implementation module is going to be, I don't know, Twitch, right? And then the only thing we need to define is like a let uh, handle message or something like that, right? And then in here you will get a param, like will be the data, and that will be each one of these lines that we're trying to get. So all of this, right, receiving and splitting into lines and so on, we would not need to do anything like that. That would be awesome, wouldn't it? But let's build at least one this way, right, that works, so we can say like, all right, that interface does make sense. If we have evidence that it does make sense, then it will be so much easier, right, to do the right thing. So the least amount of abstraction that would make us the most productive, right? That inflection point. Same for types. Okay, so we probably want to say if raw is empty, right? Then we'll just return no commands. That's not the problem? Is a problem that we have an empty string here? For this, then that. Well, that's troubling because I thought we removed, right, all of the empty strings here. Filter, right, returns the elements that satisfy the predicate. Oh my god. String length, right? Part has to be bigger than 0. There we go. No, sorry, Leia, that was not for you. She ran away when I said that. Okay. Isn't that pretty cool? Leia is my cat. Or, okay, she's not my cat. She's the cat I'm cat sitting for. So you can tell I'm in the kitchen right now streaming. Yeah. Not very comfortable, but we make do. You want food? One sec. I'm gonna go put some food for her. And we're back. Okay, so we get the caps back, which is good. And maybe, but we're building all this stuff on top of Riot, OCaml Riot. Where is Riot? Fuck, I had it open somewhere, I promise. Here. There you go. And PF works with EIO and LWT, I think. So it doesn't work with Riot. I love PF. I love Antonio's work. Yesterday we were building Blink, right? An HTTP client for Riot. And my God, the complexity between HTTPAF, the fork, gluten, and PF was just like mind blowing. I'm not that smart. On the curve, I'm pretty much on the left. So we built from scratch, right? Like what we needed. Support for clear sockets, SSL, right? We only have HTTP 1 right now, but adding HTTP 2 is a matter of filling these two functions, maybe a little more. Oh yeah, for the military, yeah. I saw that. I learned about that recently. Oh, speaking of domains, let's see if OCaml AI is working. Ready? Refresh. We did that. We totally did that. Dax and Diana. Unless I have either, oh, this would be terrible. But unless I bought the wrong domain, which I don't think I did, don't look on my password. It's the same domain, OCaml AI, right? No, Leah. Not today. Not right now. Dax, inescloudflare.com, Diana. In the domain, yeah, I use the templates. So like they have it there. Save changes, right? So I don't have to type anything myself. Fun fact, in case you didn't know, Dax and Diana are Star Trek characters. Jadzia Dax, DS9. Science officer, she's a trill. It's a species that has like a symbiont worm thing that gets passed across people. And Diana is Diana Troy from TNG, Star Trek: The Next Generation, and she's a Betazoid. She can read minds and stuff like that. I was like, oh, that's fun. But yeah. Okay, I might need to do this off screen. Don't know. Usually, this is so fast. I don't know what happened there. Okay, I want to close that. Whoa! Udu Udu, subscribe with Prime. Thanks. Thanks a lot. I don't know if you could see the. Oh, yeah, there it is. The little reaction. Anyways, so we wanted to do a print of the command, right? So we will do command to string. But if it's a password command, right? I'm confused. Oh, dummy me. The replies are fine. It is the commands that go out. This one's right. That we want to print here. What? Did we already turn them into commands? No, we do command. And then we get commands there. Right. So here we will say, oh, we have command to string. Okay. So command to string, okay, that's the problem. Command to string is the actual serialization of the command to be sent over the network. Now, Leia, now. But we want to debug by doing print command, right? Data. There you go. So now if we add something like pass here, hello world, then we should just see pass redacted. Whew. Dude, don't do that to me. Chat, did something leak? Instantly stops the stream, calls the police. All right, so connection gets closed after a while. So we'll make a config. Now, Leia. Now, Leia. Leia. Now. I don't like doing that, but pass super secret password. Okay, so now that we can do that, let's try to authenticate. Authenticate. We just need to parse the replies that come back and make sure that they are all okay. Oh yeah. I mean, most likely I will just change that token to something else. Nothing here is like prod ready stuff. So you hear me? Nothing here is production ready. We are messing around. Anyways, so now that we can send those messages, right? We literally need to get them back, get the replies, and look at them over. Yeah, look at them. Damn, 170 words. That's a lot of words per minute, man. Too bad you can't think that fast. Bet you didn't see that incoming. And authenticating, we need to see the messages that come out, right? So we just, in this case, if we do okay, then we'll see what messages come out, right? The replies will get logged anyways, I think. What? Whoa, look at that. Super secret password, it definitely got leaked. Fuck. Oh my god. I know, I know. Jesus. Jesus fucking Christ. This is a terrible thing to have there. It's great for tracing, but ah. Jesus. Ah. All right, all right, all right. So we'll go from trace to debug. And this looks nice, but it's, yeah. So, warning, no trace or leak. I think the best thing we could do is go to the network layer, right? NetML socket. So we have a sending. And here, we will just say we're gonna send this many bytes. So if you wanna, yeah, if you wanna check how much, what you send, that's up to you. Ba-ba-bum. Fix do not log out what we send on sockets. I know, right? It's a good thing that I planned ahead. I'm sorry, I just installed you. What else do you need from me? Nice. So no one's gonna send you your password until they do. Okay, if they do, then we deserve it. Everybody ready? YOLO. Improperly formatted auth. And I think I know what the problem is. Command to string, right? Should actually be doing auth like that. Woof! No, login unsuccessful. To be honest, the trace is not really that helpful here, anyways. Login unsuccessful. I really thought that was gonna work. So this is what we did to get the token, right? So the format is good, but the token we're sending is not what it expects. Yeah. And we are doing pass and then nick. And the auth is there, so the format is good, right? And we have cap rec and everything. Let's see, login unsuccessful. Fuck it, I'm just gonna copy it. I do not know. No, that's not the thing. Okay, let me double check that. Going off screen. Boom. Twitch token. Oh, they have a mock API. That's amazing. Damn, Twitch has a ton of APIs. Implicit ground flow. Um, don't really see like scopes anywhere in there. Okay, Twitch access token scopes. We want to get chat scopes, right? Chat and pops up. Okay. Um, we can start with view like chat read. Nope, that didn't work. I might need a user bot maybe. Twitch login unsuccessful scopes. Let's see what the internet says. Oh. I need a user token, but I instead have something else. All right, trying out the new token. Nice. Thank you, Your Life Matters 2024. Thanks for the follow. All right, so I think we can go back now. Thanks for the save, Nixflakes. So we failed to parse this thing, which is fine, right? But that's the message. Let's go. So we want to go into parse error, right? And the message we want to parse here is, I think it's going to be always 001, but then we have username, right? And then we have welcome, cool, have fun. And this will be login successful, right? We don't need the username really. Actually, it won't be like that. It will be like that. And we expect that to be the end, I believe. So in the replies, we want login successful, right? Oh, we're going to have a bunch of those, aren't we? That's fine. So we have 002. It's the second message. So we don't really care about the message number then. And then we'll say your host is TMI Twitch TV. And I think, we'll see. But I think I like it better when we do. No, what the fuck did I do? Like that. What? Select colon, and we're gonna do double. Okay, so the syntax just converts that. And this will be welcome. All right, so I think we're gonna need a better way of parsing the commands, right? Because right now we're doing a pretty dumb thing where we're sort of buffering everything and then splitting by lines, right? And definitely are multi-line commands here that we want to get out of the way. So we'll do a little recursive descent parser for this, and it will be fine. So instead of doing all this stuff, right, we'll just do parse commands, and we'll carry around the commands there. And parse commands is gonna get a raw piece of string, and we actually do have the bit string module available, I think. Preprocess, PPX. Cool. We're gonna use something like this, which is fine. So I'll just grab that, and we'll do. We know how long the host is, so we're gonna expect an exact TMI Twitch TV, right? Let me open it side so we can see the messages. And this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 by 8 in size, right? And then rest is going to be a bit string. So we're going to drop the header out of all of that. And then the next thing we're going to do is we'll parse and we're passing the rest and the accumulator. So now the next thing we want to do here is cap, right? And this will be 3. Actually, cap neck like that. So 9. And if we get 9, then actually 10, then we'll get the rest. And the rest, it will be parse. Actually, the rest are just requirements, right? And so we can do okay, right? Cabnac, Rex. So we start parsing here. We match on the first part. We keep going. Isn't it bitstring? I think it is what it should be. Let me just go to Nomad quickly, because we had an HTTP parser here that is written with bitstrings. Yeah, match percentage. It's like that. Literally like that. And the rest is -1 in size. Okay, it might work in a second. Now, if we have cap ACK, then it's kind of the same with ACK, right? Now, if we do have a notice, and I think there's a space here, so we can do 15. If we have a notice, right? And this will be 1, 2, 3, 4, 5, 6. Do I have something? Yeah. Showing me 10 by 8. A string. Then we can grab the rest, and that will be our message, right? So okay, notice message. I think we can make this a little easier as well, because we need to parse the requirements in the exact same way, but one thing at a time. And now the other thing is, if we get a message, right, that begins with a number, right, and that will be 3 bytes, and then it's continued by a username of I don't know how many bytes, so we can't really match that, right? I think we do separators just like that. Parse message, and then we'll just pass in the rest in the accumulator. And the accumulator makes sense to have. Does it make sense to have? Maybe not. I think not. Because we're not going to recurse. And parse message, right? Parts. Nope. Message. Could just call it message like that. All right. Leave chatty, leave Dune. We have the PPS. What the hell? And when we get a message, then how far do we want to go with this? How far do we want to parse those messages, right? Because I see the output here is pretty big. Here. I think until we find global user state. Would that be fair? Just that we be confused here, right? So we done those three. That's fine. So we want to drop the username. And that's sort of going to be, we want to drop one byte at a time until we match an empty string, right? So here we should start with you're welcome. So if the message begins with you're welcome, go have fun, right? Then we're gonna grab the rest and we're just gonna ignore it. And we're gonna say, all right, this is a login successful. And this will be do parse message, so we can do try do parse message, right? And if we parse it right, then we get a command. Actually, I think we can drop the OKs everywhere. So just return a message, right? And if we have any kind of exceptions, then we'll just say error, parse error. So this will be command. These are the commands, right? Plant. Command, parse responses. What the hell? Why is it called parse command? Do parse response. And then we should get one command. Right, this is why, okay, makes sense. This is why we wanted to have the accumulator. We will return OK commands, right? But as we go finding commands, we just put them in the accumulator and recurse. Go like, all right, let's just keep parsing until eventually we'll be out of a string, right? So this will be match, right? This thing with either we get an exception here, and then we say file to parse, or we do get a value and say, okay, that's the commands. And now we can actually nicely do that. Message. Sorry for the formatting mess. Just A little chaotic using this syntax. Okay, I think that actually parsed. Invalid number of fields in the statement. I think that's fine. It's like current string, like this. One, two, three. Wait, what's the syntax? String colon size colon type. And we got 15. 15 by 8. Yeah. Unless it's the other way around. Nope, that was right. What are we listening to? Oh, the making for. Okay. No, we don't want that. All right. We said we were going to listen to some Yes the other day, and we never did. So, watch out, everyone. Things are going to get weird. Bam. Bam. 16? 14? What are you complaining about? Invalid number of fields? Oh. Oh, well, this sucks tremendously. Ah, yeah. Okay, so this is not going very well. I generally prefer. Like, I think building parchers like this is great, but OCaml doesn't have first class support for this kind of pattern matching, right? So we usually end up doing things like um, parse combinators, for example, right? Or recursive descent, where we like wrap the string in a buffer or a lexer or something like that, and we pick tokens from there and advance a pointer to know where we are in the string, right? Um, this is a lot more declarative. Like, I expect this many bytes, right? And then grab the rest. Okay, just put that in here. Unfortunately, that is not always the case. But this does allow us to say, I'm gonna grab the entire string, and if I see welcome, good luck, have fun, then I'm gonna advance until I see a new line, right? Or maybe even the end of the message. Here, right? So this is not working very well. Let's go back. Let's see if we can find another pattern for doing this nicely. What we had worked okay, but it has a problem that it splits strings, right, and tries to parse each one of them individually. So it might be easier to, instead of doing command the string, right, after having parsed the commands and having them split, we would just say, here's the parts, just like, here's all of it, really, right? And if we do that, we might as well do this. So we'll just split the entire response, right? And if we find that it begins with hello, good luck, have fun, then we'll ignore the rest of it. So 48, we don't have a part, we have a response. And replies, when we do command, so parse responses, right? Mm-hmm. Cool. So we go grab one line at a time if we have enough lines, right? line. Then we get that, but we will recurse because we know there might be more. So we'd say lines, and then we'll put this at the head of the accumulator. And we'll do the same thing here, parse lines, right? And same here. However, if we find login successful, we'll ignore the rest of things. So we'll literally just return login successful on top of whatever we had done before. And this will be a character. And once we're done with that, we'll do a list reverse. Response. Error parsing command. Cap ac. Why are you erroring? Shouldn't you be matching on Twitch TV? This should be one line. Logger debug, fun, parsing line or parse line. List, filter, fun, res, if string length, res bigger than 0, then we keep you. Okay, I think we're back. Nice. Woo! Yes, we have done that. We have created the login and we are in there. So now this will just be for a while there, and then I guess he will die. But what do we do now? We want to send the message, right? I think now we want to join a chat room, right? We want to join the chat, and what is how do I know what the chat room is? What? All right, let's try that. So in this process receive loop, right? Do we have a ping or pong or keep alive or something like that so it doesn't die? Ping. Interesting. Okay. We'll have to do it fast for now. So let's write some code here that uses that connection. So we can do join, right? and then we'll join the channel. And I think the channel will be my name here. That's the channel that we're trying to join, right? Seems to come and look like. Take a stage and so command state join, right? Channels. And we don't have join, so we'll add that. Join of string list. Join foo bar. So when we go into command, I guess the compiler should tell us what to do now. Yeah, exactly 37. We're gonna do join, right? And then we have channels. So we'll do join, right? And I think it goes that way. Also join space and just list map fun channel name, right? And we'll do there, yeah, plus channel name, channels, right? And we want to do string concat, right? And do comma separation of that. So conat should be concat. There you go. So that should try to join the chat. And I don't know how to parse that response, but that looks good. What is all this stuff? Okay. So if we get something starting with bang, I guess we might get many channel names, right? Channel, I don't know what the rest of that is, but for the time being, we're gonna say join successful or join okay, joined channel. As he knows good people. So we're joined of string, and that will be one of our responses from there, right? Oh, okay, my bad. That's gonna fail still, which is completely fine. Joined. That is not the message. The message begins much, much earlier, right? It begins. So we have one thing, really big thing, right? And then the second line is join, and that makes it so much easier, right? Because then we have the channel, right? And we can probably say goodbye to the rest for now. Woo! And nope. Yeah. Did we join the chat? I don't know where the chat is. So that kind of sucks. Using, let's see, send and receive commands. Nix, if you're still around, can you say something on the chat? So what's the name of the chat that we need to join? Dun, dun, dun. Twitch, Eric, join live stream chat. So I managed to join the chat, but I don't see myself. Do 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 do. Let's see. IRC, join chat, live stream. THRC not working. All right, let's ask GPT. Hi, GPT. What is the name of an IRC channel for Twitch live chats? Stream with username. Okay. Okay, so maybe we can send a message, maybe. Let's see the API for sending messages. Send and receive. To send a chat message to a channel room, use a priv message. Okay. So we can ignore that. Command state priv message channel message. Channel message. Okay, you ready? You got your chat app. People are seeing this. This is monumental. Woo. Safe. Connecting, sending. Yes, OCaml, my camel. It works. We actually can send shit. Excellent. Boom. Woo. Exciting. Clip that. That's pretty great. So we're creating these tiny little APIs for us, right? To be able to do things internally. Then we'll be able to expose those, right? To work from outside the process. And that means we can use a TUI, right? To drive this thing. Oh, look at that. We even see who's online right now. The useful distraction, Mandax, Spofo, Nixflex, another TTV viewer, another TTV viewer. Below the step. Ooh, that's pretty cool. A bunch of people that I've never seen before. Lurkers. She's completely fine. But yeah, good to have y'all. I hope this is not leaking my password somewhere. Wait, does it send that on every message we get all of that response? We can do something nasty here. We'll just this is a test from Chatty. All right, this actually returns something. No, it returns a unit, right? So that's cool. Hey Dylan, how's it going? We're sending messages from OCaml into Twitch. I know, right? It's pretty exciting. This TCP protocol is weird. Yeah, you can rewrite. Yeah, exactly. Yeah. I think we'll end up publishing some of this stuff. It's pretty raw right now. Like there's not many abstractions being used, right? It's just all of it there. But I can see here at least like a generic TCP server, right? That we can use for connecting and dealing with TCP protocols and stuff like that, right? Um, that's the one thing. I can see an IRC parsing thingy because all these commands are IRC specific. So if you want to do things in Twitch with the chat, then this is one way of doing that. Another way is with WebSockets, right? But I don't know. I could have gone down that path. I just didn't. And then on top of that, it's like we should definitely work together on a Twitch package, right? At the very least, to define like common types and stuff like that, so we can reuse them for different things. And this could be like Twitch sys or Twitch types or whatever we want to call it, right? I think it'd be fun. So yeah, definitely things, right? Right now, all of those different like orthogonal layers are put together into this one package module. Um, yeah, but it works, which is nice. So what I would like it to do now, instead of send message, I would like it to receive a message. So I want to try that. And if that works, then I'd be more than happy to parse the whole send message. Because when we send a message, we actually get an entire state of the channel back with like all of the people connected. That does not sound scalable. Twerple. Let's see what Twerple is. Nice. This must have a WebSocket, yeah, event sub WebSocket, yeah. Well, I mean, WebSocket is the way to go, right? If you want to build something that will run in the browser. I think now thinking back on it, one reason I'm excited about building this over TCP is that there's other things that we need to build over TCP, right? Other protocols. And for example, Postgres, right? That has a protocol that works over TCP. We can reuse and we should reuse as much as we can from Cacti, right? But yeah. Okay, so how do we get a message? Receiving chat messages. When a user enters a message chat on the Twitch, no, it did not. In the above, the first part of the message identifies. I'm not getting that. And I know when I'm not getting it. I am getting it. I'm just ignoring it. In our loop, right? We should be reading responses. Changing places. The same one world to happiness. And here we can just do whatever. So if I'm not mistaken now, every message we get will end up as a message here. But the first one is going to crash the thing. So I'm going to send a message. We're going to send an emoji. Take that, server. Okay, that did not do what I thought it was going to do. Wait, are we getting messages? Or we already failed there? We're okay. So we get a room state message. Is that what they're sending? Yeah, they're sending one of these bad boys. So let's do that. What is this? It's not a command. It's a reply. And this will be a user state, I believe. Oh, we have information about the badge, the set of emojis, emotes that are available to someone, user type even. Okay, so right now we're just gonna be like string. Wait. All right, we don't have anything to turn. Yeah, okay. The exhaustivity does not work that way. So here we would do a new command. I don't like that this is go. Cool. So this is one big string, another big string, right? And then we see user state, right? And then we have stuff we want to drop. And this will be meta, right? So maybe we want to just get the meta. And then we want to do channel, I think. Ooh. Okay, so we're gonna have to be a little smarter than this. We don't really get this message alone. This is one of the things that we get, right? But it begins with the message 353. And I don't know if that's always the same, but we're gonna search for 353. Yeah, I see it a bunch. And I think they say here something. Receiving chat messages. Okay, cool. So first is that when you do join, then we have 353, and 353 is who you are, so current user, and then we have an equal sign, and then we have the channel, and then we have rest. And I think here we want to do parse usernames. Parse name list. And this will be names, right? So join channel, we'll say channel, and then users. Let parse name list. And we can do the same. So match string, split and char. No, actually, we already have that. So we're going to go here and grab that list. So that will be our, this will even be part of the, oh, that's great. The rest is just the usernames. This is a different message, 366. Okay, perfect. So less stuff we need to do, channel, and this will be users. So we do channel, joined, and then users. And this will be channel, users, and this will be a string list. I get up, I get down. Bam, bam. So when we do join, then we want to do parse join rest, right? Cool. So we'll grab this stuff, which is the join stuff, right? And we'll put it in a separate parser. Let parse join, channel, rest. And we want to parse at least one more line there. So we'll feed in the rest of the lines. And that should be the end of the join command. Okay. Let's go into join, the type. Oh, it was right here. Okay, perfect. So we do the join, we pick the channel, and then we go on a different parser that does these two lines, right? And the first thing we do is parse join. This will be parsing the users, right? Which is good. So we have the current user, we have the users as well. So if that is the case, then we can grab the first one of these lines, right? And we expect nothing more there. And we can say match string split on char line, right? And that line is going to look a lot like this. So we're going to ignore the first part, which is always the same. And then we'll have 366, and then we have the current user, which we don't care about. We have the current channel, which we don't care about. And then we have end, right, which we do care about, of names list. And if that's the case, then we have everything we need. We have the channel, we have the users, right? I think we're gonna need to lift that up into a different parser so we can recurse. Or not, maybe you can just return that. Okay, okay, that. Else, what's the error? There you go. Oof, this is a horrible OCaml. So rest is a string. And then we have rest here as well. Do not judge me too hard for this. If it works, we'll clean it up. '84. What? Okay. Are we not receiving the rest of the messages? I guess it's possible that we don't have. It probably means that we want to do receives while we're parsing, right? Like you start parsing and then you get a command and you parse as far as you go, but you may actually need more characters than you have. So maybe this will work if we run it a couple of times. Maybe not, maybe we always get a join that's separate from everything else. All right, you know what? Let's save this parse join function because that's useful. Let's go back to the old join parsing code. Because that was working at least, right? Right. Yeah, this is definitely a separate message. Called user state. So something user state, right? And then channel, and then we have something something room state. So we can do probably those separately, but I think they're the same message. There will be different lines, but okay. So we do go lines, and then we'll say user state, and this first thing will be the meta, right? That's what we have for the user state. And then the room state is the same message, but it says room state instead. Cool. So we got user state, we got meta, and we got a channel. Cool. And we need one like this for room state. Confused, but okay. Two, three, four. Hey, tech support. Thanks for the follow. Oh, tech support sounds like tech support, right? Or how do you pronounce tech support? Oh no, this is not what we wanted. That, however, could be channel. Ay, ay. Why are we not parsing this thing? Why are we missing here? We got a user state. We have a typo. We have a fucking typo. Fuck my life. It is room state. Room state. Not room state. Okay. We parse that, and I think, no, what do you do? Somebody did something. Oh no, never mind. Nobody did anything. This is just an update, I guess, saying who else has joined the chat, which is pretty cool. Okay. So now we have a join that has multiple joins. So we just need to recurse. I would expect though that that join command be the last one. And now it fails. Really? Leave that. So joined when we have users, that worked, but then the other one did not work. What? Okay, so that worked when we just said, okay, join, single message. We stopped parsing there. Whatever else we got, right? And now we will get a multiple set of joins, right? Nice. So this is for prev message, right? Which we should have a version of that. We don't reply. And then we have the meta, which is big string, right? We have the user, which is also string. And we have the channel, string. And we have the message, which is also string. So a bunch of strings. Gonna bring that down here so we can parse it more nicely. And we have meta, right? And then we have user. And then we have prev message. Then we have channel, and then we have the message. And then that will do lines, prev message, right? And then we'll do meta, user, channel, message, and then accumulate that. Receive. We're just gonna do send for sending, and we're gonna do receive for just disambiguating them. And the message will actually be a list of strings, because why not? So when we do in line 158, we'll do send private message. Nice. Please don't say a word. Right, we're missing the 353 message that we had here, right? Which, thank God we saved that. The hell was this? 353 Current user, channel, users, go lines, and these will be joined users, channel users. And then we'll do accumulator. So we get everything there. That sounds really cool, Jawar. Thanks. I personally don't mind. Like, I don't really like the. I prefer to pass my accumulator around. I think it just helps me think. But it could just be that I'm used to do it, right? So maybe tail emoticons. Uh, maybe that will be the new thing to get used to. Great song, right? It's like very moody. Like it has, I don't know, ambience, or I don't know how to describe it, but I always feel like with Yes, it just takes me places. You know, it's like a little journey. Possessing. Cat hair everywhere. Whoa, that worked. I sent a message and we got it and we processed it and we didn't crash. Guys, look at that. Tech support has said POG. Oh my god, it's working! It is working! Woohoo! Nice! Well, I don't know who did that, but thank you very much for ruining the party. Was it tech support? Yeah, we just have a bad message here. No worries. This sounds cursed. Oh, no, it's fine. It's just a bunch of join messages, one after the other. But maybe it looks like it's incomplete. Okay, so we're gonna do some changes here, right? Oh, well, let me clip that. How do we do this here? We, receive message, right? Maybe we want to keep receiving, right, in the buffer until we have a new line, right? I'm not a fan of that. This is why the receiving and the parsing need to go hand in hand, right? Because the parsing actually instructs the receiving. Kind of like when you're building a parser for HTTP, right? You know the protocol and you know that you can read pretty much everything until a double new line, right? And that's going to include the status header, the path, the method, right? All the headers really, right? And then you can stop there, make sense with that, right? And in there you will find a content length, for example, right? And if you don't find anything in the headers, for example, that tells you how much the body is, then you can continue reading, right? After you parse that, you can continue asking for data and accumulate the data, right? Until you get to the um, it's a double new line, zero double new line, right? And this is how they represent. This is the end of the body. So we probably want to do something like that, right? Where we will read until we have a new line, right? And we will cut. Essentially, we will. Should we cut the last new line? No, right? Okay, help me think through this, right? We have this thing here below. And this has new lines, right? But this one does not. So maybe when we do parse responses, right? Instead of immediately returning with a parser, right? Where is it, parser? We can just say, all right, this is the stuff that we don't know what to do with anymore, right? Like here's the rest of the stream, the data. Accumulate that, right, and then try again next time. Probably would be better to not do that and instead ask for more data until the last thing we have is a new line, but we might not always get a new line at the end. If we get more than the last new line, then we can grab that and save it for later, because we clearly have not finished parsing that particular response. All right, so I think I'm gonna do that. So we receive, we get a buffer, we turn that buffer into a string, right? Parse responses is doing some work here that I'm gonna lift out of it. So I'm gonna make this one recursive with an accumulator, right? And I'm gonna rename it to parse. So wherever we said go, we're just gonna say parse. And the reason is that I'm gonna move this stuff, which is a little bit of pre-processing of the lines, right? One level up. So I'm gonna move it here. That's gonna be called lines. And we can do an if equals empty, then do that. Else Nope, sorry, we need the matching. Sorry about that. We need the matching. And this will be line. So our promise here would be that if we're calling parse, right, then we will always give it commands, right, that end with a new line. So here we can do match. Maybe we can drive the parsing from outside then and just keep it one line at a time. Does anything here require more lines? Yeah, we do. Okay, so different heuristic would be we check if the command ends in rn, right? And if it doesn't, right, then we split and we grab the last thing, and that will be our carryover. So if string ends with, and the suffix is rfrn, right, for row here, if it ends with that, that is excellent, right? So we got the lines to parse, and we can just parse lines. If it does not, then we need to get everything but the last. Okay, has carryover, or similar but slightly different idea. We would actually make our parser, right, take a has carryover flag, so when we need to parse one, and this function will be parse one, right? If we fail to parse the last thing and we have carryover, the carryover flag, then we just return carryover. And then carryover here will be nothing, right? But if line is the last line, right? Then we can do parse one, right? Line nothing, and accumulator. And this thing here will be parse one. Cool. Yeah, yeah, yeah. Look all the recursion. Carry over. Plus that. Can't find the symbol. There you go. Oh, not ends with. So we're parsing, right? If it does not, we probably want to log that. Logger debug as carryover. Boolean. False, false, no carryover anywhere. Just error parsing the command. Okay. We probably fucked that. Which one is this? This is a 353. Oh, we're receiving a 353 without the other message. Interesting. So maybe. So maybe we don't need the other one. I mean, by protocol, some things are there, but maybe they're not always needed or used. So we send that, we get the message. Dino dance. Okay, so Chat. Can you post stuff and see if we can break it? Even if they did EIO Dream multi-domain, you'd still be running every request on a single domain. And everything else you do will lead to start orchestrating itself across the shared domains for it to be multi-core. It is not the way to go for practical multi-core applications. Woo! We got a PR! Amazing! Oh my god. Thanks. Reviewing on stream now. Quote. Let's see. Hopefully it will be, ooh, amazing. Benchmarks are way too synthetic. Yeah. Perfect. We're gonna add rule. No, we don't need the rule now. Let's see the code. This is using third-party libraries. That's cheating. No, it's fine. Standard stream. We get a listener. Cool. Yeah, we tried this. We definitely did try that yesterday. Using Tokyo IO copy buffer and copy. And we did not see that it was considerably faster. So maybe this Socket 2 library is doing something cool under the hood. But let's see what else is updated here. Good point, though. Very good point. Renaming this to Rust Tokyo. That makes sense. I don't know if we can actually rename that on the PR, but we'll just drop a comment here. Good point on renaming to Rust Tokyo. Check. We'll do. Okay, we forgot to parse the ping. Oh no. Fee bench improve Rust benchmark. And what was the name of the PR? PR number 5. What? Oh, this is creating. That's what's happening here. If I do squash merge, then what? Oh, nice. Config, buffer. All right. That's hilarious. But yeah, it is what it is. We can just merge this. I need to address this at some point. They're saying that they have Golang handling 1 gigabyte easy on both of them. Yeah, naturally, if you're on bigger machines, then you're gonna have better performance, right? Or different performance at least. Cool. I will put this on the side and address it at some point. Don't have the brain power to do it right now. It is baked. At least on my machine, that benchmark is doing numbers though. But I need more folks. I need too much to explain. Too much to explain. So we did that. Okay, we can come back to the ping message. Ping. Okay, that all passed. Perfect. Which makes sense. Where were we? I want to close that. Let's parse the ping message. And the ping message just says ping. So the first thing we get there is ping, and then we get a server, right? And eventually we'll probably want to capture that server and prefix everything with that server. So we probably will have to do that. So if you're in multiple servers within the same sort of session, oh, just you're a second too late. Chat, chat, you're a second too late. We had a failed ping message here, and this would be ping. But we'll fix that in a second, and this will be just a ping. Go for it. You want to see your message? It'll be right here. And thanks to the amazing text input, right, that Tom built. Woo! Look at that. Hello. World. Pink. We have a pink here as well somewhere. Obviously, there's a lot of noise, so you can't really see much. But if I go below here, here's the ping, here's the world, here's the ping again. So now that we have these very basic things, look at that. Test, test. Woo, new line. Someone's trying to break my stuff. Oh, we even parsed that thing. That's amazing. By the way, this multiple case is Brazilian for laughter. I am laughing. Okay, so thank you so much, chat. Thank you so much for that. That was great. So next up, right? Now that we have all of these messages written for Twitch, even that pop Nemo, that's actually gonna pop up here, right? As whatever you type, which is pretty nice. Now they have all the stuff, right? And we have it in the read response loop. We want to be able to get the messages out of here, right? Out of this process. Oh my God. Mini heart attack. Mahler VZ. No, don't do that, please. We want to be able to grab the messages, right? And send them to another process. Because right now, right, our main is just starting chatty. It's going to start over now. But really, what we wanted to do is to start also, right, the chatty TUI applications, right? And that doesn't exist now, but we're going to make it. And our chat TUI is actually going to let us... Oh, wait, that's a... Can you repeat that one, Kai Imperial? That's a great one. If you want to send some Unicode stuff, that would be awesome. We'll just see how it breaks. Okay, so it's a reasonable implementation. Seems to be running, right? No crash yet. And we would want it to... Now we want to do some things, right? Like we would want to be able to have an API for us consumers, right? To say Twitch, right? Send message. And then you say Twitch. And then I can write channel, right? What channel I'm talking to. And then message, really, right? So hello world, something like that, right? Like that. And I would like to read messages. Like I wanted to maybe even keep track, right, of the messages that it's getting. And the reason for this is that this will be the public API, right? So from the outside, we would call chatty dot send message or stuff like that. Look at that. All of your scapegoats and stuff is just no breaking. Hey, Kontoren. Nice to see you around. People are trying to break the chat here. Look at this. There's a lot of noise, but if you skim through this, you'll see that you can see your message. Kontoren is right here, right? KI. we have built a TCP IRC bridge to Twitch. Camel with Riot. I know, right? It's pretty cool. It's pretty cool. And now that we have that running, we just want to put a nice layer on top of that so we can sort of call it from the outside, right? And build a sort of an actual TUI where you join, right? Ooh. Okay. So let's do that a little bit, right? Let's sketch that a little bit. We know how this would work. So these APIs are there and they will be fine. Save. We're gonna do the TUI now. So actually, I would even say that this entire Twitch thing, right, that is a separate application of its own. So we can maybe even do that. I usually don't have a lib folder. I like to have a folder with the name of the application, like Chatty, right? So in this case, we can do Chatty, and we move that into Twitch. And then we'll make their Chatty. Copy Twitch and Dune to Chatty. And we'll move Chatty to Twitch. So now that module will be, right? This will break. We don't really need that. Ooh, we need a dependency on Riot, that's all. Cool. And then Chatty has a Dune file. And I guess here we'll have dependency on Minty. We may have auto dependencies, but right now that's it. So we'll do in our bean main, right? We will just start Twitch. And then we will start Chatty. Cool. So Twitch now, right? This will be our protocol module. Protocol, really? Maybe not. But maybe it's time we split some of these things out. Or not. Could just leave it there. Oh, I think the problem is that being Dune doesn't depend on... There you go. Perfect. Chatty.ml. And then we'll do name, and this will be Chatty. Just like the name of TwitchML is going to be Twitch. Right? And then in start... Yep, I'm using Tmux. I'm a Tmux user. Here we'll just do OK, pitch, and we need to actually spawn something. Cool. So that starts the chat server, but we'll also start our process here. So we do logger, write debug, fun f, Chatty app started. Twitch debug. We can probably get rid of that. Is info not working at all? It is working. Whoa, Chad followed us. Thank you, Chad. Thanks for the follow. All right. And with that follow, I'm going to take a 5-minute break to stretch my legs and get some water or probably get a Red Bull or something like that. And yeah, so that will be that. When I'm back, we're going to continue building the terminal UI side of things. And I'm thinking we could build it like a little REPL, right? So we just have a cursor at the end of the screen, right? And you type things there, messages, right? And that is not very TUI-y, I guess. But Meteor still doesn't have like layouting or click like mouse event support, right? So the best we can do right now is keyboard-driven things, which makes sense because we're in a terminal. And we could say you join, and then as the messages are popping in, we're just like listing them, right? So we need to keep track of the messages as well, right? And we can leave. I think that makes. I'm not sure if that should leave on the UI side or in the session side, right? Which is like the process we already have written. But we would need a way to get the messages to be able to show them, right? So we might duplicate that. I don't know. We'll see. What else? Yeah, and then you type something, right? And then you press enter. Boom, and that will actually show you. We could do some parsing in sense of we could use escape codes, for example, right, to show things. No, partial combinators. No, bad idea. Just do recursive descent. You'll be okay. I promise you'll be okay. It might take a half an hour extra to write, or a day more to write, but it would be so much easier to look at later, to maintain, and anybody that has never written a parser in their fucking life will be able to go there and say like, oh, this is functions and data, and you're like clearly moving that pointer and stuff like that. I'm using the Twitch API, right? And Twitch API implements IRC servers. So at the beginning of the stream, we had a choice. Either we build a WebSocket client, right? And we go down that path. Or what we really want to do is build this chat, right? Or we just build a TCP server for IRC. And that seemed way easier. And so we did it. PC, like parser combinators are easier to reason in the same way that parser generators can be easier to reason, right? Or just having a formal grammar somewhere can be easier to reason, right? But error messages, pain in the ass, right? Actually understanding the performance that it will have, pain in the ass. Optimizing things or having edge cases in your grammar and stuff like that, pain in the ass. People will say like, oh, but your grammar should be LL1 or whatever, lollipop. Real grammars are messy, right? So I'm not saying you cannot build good things with parser combinators. I'm saying, Yagni, you ain't gonna need them. You mean doing recursive descent? I'm OCaml Tracer. I'm picking the least powerful tool here. Actually, the OCaml Tracer is about assumptions. Well, you know which one. Nah, I don't know. Definitely, you would not need a PhD to control. Yeah. Every time I've built written a grammar with like Menir, for example, parser generator, or I've looked at grammars with like Angstrom, right? I've just been like, so I need to put a lot of energy into it, and I understand that it's more for like it's cleaner, right? And you, but you are willing to put more mental energy than I am. I am not that smart, right? I'm just really stubborn, right? And when I get presented with these pieces of code that ask so much of me, what I think is you're being an asshole because you're not being respectful of my time, right? And I understand. I understand there's technical merits to both sides. But if you just give me functions, right, and you give me a lecture or somewhere that I can move a cursor over that, anybody can work through that. Anybody. It is co- conceptually, right, cognitive, much less, right, to put on your on a reader, right, than working with a parser combinator, than working with like a parser generator and stuff like that. Especially if they have to contribute. Look, I'm not saying don't use them. I'm saying think. Can you please think of the Grogs, right? It's like people say, "Oh, well, I don't like types," and that's fine. That's completely fine. You can build great software without types. I've seen people build massive monoliths, like behemoths, right, without types, and they can think through that, and I can't. Without types, I lose track of what the hell I'm doing and how I'm structuring the program, right? So I need that to help me. I, I mean, maybe. For example, there's this library, command liner, and it's the toppest of qualities, right? And it has an applicative interface. And I don't know if we can go to the tutorial here, right? And you're sort of building these terms, right? Let's see if you have some more examples here. And then you eventually do this type level computation of applying that function, right? By applying all of these little terms that you were building, right? So at any point in time, you can look at that, the type that this message will have in this case, these arguments, right? Or this term here. And you will know, okay, so, you know, const chorus, that will be, I guess, our function chorus in this case. Yeah. We'll have one parameter, which is a count, and one parameter, which is a message, right? Yeah, it's a function inside a box. And then you look at each one of those, and you'll have a lot of information packed there and so on. And it's pretty amazing, right? In that sense. Because you end up with supreme type safety, right? And I've written about this in the practical Rescript blog when talking. This is so baity, but yeah. When we talked about declarative command line tools, right? What makes an API declarative, and so on, right? And we go from, where is it? A new type for read. Somewhere in here I have the example. Okay, so maybe it's not here, the first one. Oh, sorry. It begins in the one before. When we're talking about building bindings to an existing package, right? So we're still talking about type level things, but we have a way of doing raw bindings where we're saying, hey, this is the function that's there, and I'm sort of going to mimic whatever you're giving me. So when we do these raw bindings with like literally a variable on the return type, then however you use them the first time, that's the type they get. And in ReScript, that means we can do some things like this, right? But that's not very type safe. And it works its way up to typing the parse arguments and having a little more structure, having ad hoc typings for objects we know the type of, right? All the way to this other article, right? Of making things declarative, where we actually build something very, very close to command liner using an applicative interface, right? Here. This is it. That's the applicative interface, right? You give me an argument that is a T of an A, and then as long as you apply that, right, with a position on argta, then I will do this type level computation of applying that A to that function, right? And I will give you a B. And that looks pretty nice, because at the end of the day, you can, I think I have a screenshot of the type, it says somewhere here. Yeah, here, right? If you say clipper command, say hi, then you get that. However, I, as a user, right, of this library, now have to understand how the fuck does an applicative work. And that is terrible. That is absolutely terrible. Because most people don't want to know what an applicative is. They just want to build a command line application, right? So there's something I refer to a lot called laws of UX, right? And there's a couple of laws here that are relevant for this. For example, one of them is Jacob's law. And there's a lot of HCI studies and references for this, especially from the Nielsen-Norman group, right? Where they say, hey, Jacob's law says that developers spend most of their time on other libraries, tools, programs, whatever you want to call it. This means that developers prefer your library, tool, program, whatever, to work the same way as all the other sites. Now, I'm not saying it has to be 100%, but you could go like up to 80 at least percent to make it more familiar for people to use and to get stuff done, because nobody wants to learn about applicatives. They want to build a command line application. If you use applicatives inside, amazing. CVR, thanks for the follow. There was one here specifically about how many things you can keep in your head. Miller's Law. This. I think fractals are good because it's the same thing and you reapply and reapply and reapply, so you don't have to learn new things or keep more things in mind. Oh, this is an ORM. I personally think ORMs are a bad idea. Just write SQL. But that doesn't mean that you cannot do ORMs well, right? Let's see. So this is a database interface, begin transaction. Are they good or are they convenient? So what am I looking at here? What am I looking to get out of dbmonad? Okay. You mean the then method? Like that would be the extent to which C# can do monads? Flat map then. It depends. There's a lot of things that are monads that people don't know about and they're happy to use. Like Rust has option and result, right? And futures and promises are monads. They behave as monads as well, right? In most languages. The point is, Yeah, lists. Lists are monad as well, right? The monad box is here's the query. Let's see. Okay, so when you start a query, you build a query, and then you can do then execute non-query or flat map, and then this builds another query, right? So this is essentially like what will be the monad here, right? When you do this flat map, this join operation, right? What does it mean? Because in results, when you have two values, right, and you map over one to get the other one, right? You're saying if it's an okay, yeah, I understand the flat map is fine. Um, in the result, if you get an okay and then you're binding over something or flat mapping or and thenning, and you get another okay, that's good. But if you get an error, right, then it returns the error. Okay, so this means that if I make a query, then that will return a query, and we're sort of flattening the queries together, or like replacing the first query with the second one after the first one runs. Sequencing them. So just so I understand, right? I'm gonna open a new file here, full screen. You're saying that if I have a query Q1, right, and then I do flat map, right, Q2, right, then this runs Q1, then Q2, right? Okay, I understand what you mean. So it's trying to hide, right, the connection in the context. So I don't understand why this specifically has to be a monad. This sounds like it could have been a future, right? But if you need more context and you can put more things in that context, then that's fine. Flat map, however, is a horrible name. Horrible. I hate it. Everywhere I look at it, the only I think abstraction or monad instance where flat map kind of makes sense is lists, because we're using of thinking of flattening lists, right? You flat and then you get this, right? But if you have like a future one and then you do flat map, that flattening doesn't make sense. I think Rust made the right decision calling this and then. Bind is even worse. I personally would rather have methods, right, or functions that have names that maybe behave like bind or could be called bind, but they're called something relevant to the context of that monad, right? So here, instead of flat map, this could be sequence, right? And if you say, hey, I have a query, I'm going to sequence that with this auto query, then it would be obvious that it runs the first one and then the second one, right? Because what does flat map do on queries? I don't know. I've never had to, like, I don't think there is one interpretation of that. You could argue that sequence also is, uh, ambiguous. And so it could be, I don't know, running chain, running order, right? Or it could be and then, or as well. I forget what Ruby calls Ruby list map. I don't know if it was called map. Transform, yeah. Some of them are so used, right? Like map. Anyways, so now I'm gonna take the break now. My legs need it. No, fuck, I closed everything. Chat email. Oh, we had a message that we didn't parse there. Cool. So we're gonna add that one last message, and we're gonna leave this thing running and see if it breaks somehow. TUI parse, and the message was like this, and we'll get something, and then it will be part, and then we'll have the channel parse carryover, and this is a part, right? But yes, while I'm gone, think about this stuff. The lots of UX are amazing. They definitely are things we need to bring into DX developer experiences. Not verbatim, because most of this is typically applied to visual um, visual load, right? Cognitive load. But we have a couple of things that are interesting. So I'll drop a link on the chat. Also, I think I'm hungry. Elmar is my love. Okay. Thanks for the follow. Muting in 3, 2, 1. Chat. I just realized, I haven't eaten in like 8 hours, something like that. So I'm gonna have some food. I will be back in 20 to 30 minutes. If you have any music requests, then just drop a link and I'll make it happen. Else, I'll see you in a little bit. Hello, folks. We are back. Setting up over here again, and we will continue. Gonna do a quick change of mood. I'll play some old Whitesnake. What's the name of the album? Trouble. Ready and Willing. That's a good album. All right, 1, 2, 3. We're going there. I was born under a bad sign, left out in the cold. Yeah, yeah. Mm-hmm. Okay, so we had put aside. I think there's a little bit that we need to do here in the loop, at least in the loop of the server, right? Because right now we're just reading responses, but we probably want to also check them, right? Like you get replies here, and we'll see if we get a ping. We want to do a pong, so the connection does not close. So we could do handle replies, right? And we just pass in the state. If it's empty, we just go through the state. That's fine, right? Just actually, we just return loop state. If we do have replies, and the first of them is ping, right? Then we absolutely want to do a pong, right? So we'll do a pong state, just like we do this join and so on, right? Most likely those will have to go up above the loop. So let's do just like we have join, we will have pong, right? And that just says pong. And that's a message we need to create. So let's go here. We'll do command pong. And this really is just pong. So now we can come here and add it, say pong. It's gonna be pong. We can go back. When we do pong, we don't really need anything else. We just do pong. Pong, pong, pong. We don't really change the state of the server either, so this will just be like, if pong does okay, that's fine. We don't need to parse responses to pong. Pong is a response to what they're saying, right? So we can just say handle replies, and then do replies state. For any other reply right now, right, we're just gonna do the same. Just gonna skip it. So now this should read responses if we get anything, right? And as soon as we have complete parse responses, iterate over them, right? and try to respond with pongs to the pings. Cool. So what we wanted to build now was the actual chatty TUI application, right? And there's a couple of ways to do this, but since we're building something on Minty, then that means we get access to all of the Minty nice examples, right? Cat hair everywhere. So, for example, the newest one is the text input, which is a very nice one. We're gonna bring in also leaves, which is and spices, which are the spices. Do we not have spices installed? 9. Palm install, and then spices. Palm. And we'll install leaves as well. So then we have the TUI framework, terminal styling library, and we also have the component library. So this will be our current message, right? And we'll just start modeling this. We need a current channel, we need a current input, current message. We will do no such thing when we start, and then on every event, we don't really need to do that like that, right? I think we can remove that wrapping. We do want to do something like, for example, event, key down, and we'll do a key here, right? Q or escape. And we'll just say model quitting true, right? And then command quit. However, if we have a frame, we want to tick all the components, like this one, for example, right? We can remove that. Current message. And our UI, for the time being, I think for the time being we could just use the default. We cannot really use Q here, right? But we can use escape because we are, you'd be typing. So for the time being, that'll be that, and then we do current message. So here on the right, we should have hello world, and we can remove like what we're typing, right? I think there's a bug there, but no worries. So the next thing we want to do is to not start Riot twice. And right now that's doing this, and we don't want to do that. So we'll go into Minty, right? Because I don't think we're exposing your program. Yeah, okay. So there's a small problem here, because we want this, right? So we're gonna need to expose the program, not the whole thing, right? Just the run function. Hmm, interesting. Puts module name in identifiers. Oh, that's super cool. So it canonicalizes the messages, the names of the messages. Cool. So we just want to infer the interface here, right? So we can remove that. And we're going to Minty, the full interface. And we're going to go into module program. I'm going to say, okay. A program, right, has this interface. So there's a type model T, right? And you can create one with this. And then you can run it like that. So model. And if we go into MintEML, right, then we can just say module program. Different format. Cool. So with those changes, right, feed expose program T. Maybe we don't need to do that actually, just 1 second. Because what we want is to be able to expose this thing, right? So that you can create your own app, right, somewhere, right? And run it however the hell you want. So we could do something like this, right? Initial model, and then in here we just create that and call it. So then we keep the program internal, and then we just keep you a function to run your app. But I think maybe this is better. So then you have two functions. I'm not sure I like this better. It is less of a smaller API surface, right? All right, let's go with this for now. So it's less stuff to share, right? Feed allow running up um, directly. And we have a typo there. And now we can do an install of Minty, right? Oh, I heard a ping on the chat. Let's see what that was. Hey, Scary Human and Parogen. Thanks for the follow. Oh, the OCaml man is on the stream. Red Bull cracked. Oh, you saw that. Okay, so I know, right? It's coming together. I'm super excited about that. 4:34. I am behind with the messages. Sorry about that. Didn't have the app opened on the phone. And then sometimes I need to restart it. It just like lags. Anyway, so we have that there, right? That means instead of calling app and start like that, right? We can just create our app here. We can say no logs. There will be 0 logs, right? And in here we'll do minty run app, our initial state. Actually, we can even create it there. It's fine. Play the code. Doing clean, doing build. I'm sorry. You make different assumptions over leaves? What is this nonsense? Doing tests. We don't have tests, right? Yeah. So what else? We need to install Minty. We just did. And you're telling me that Chatty I think maybe, just maybe, the fact that leaves now depends on Minty, right? Right. Leaves. And I think I'm gonna have to pin spices as well. Yeah, exactly. Spices. Yes. Build. All right. Let's see now. Perfect. So run. Initial model. Okay, cool. So that means that we have this, right? And if we press Q, then that quits. But it only quits the app, right? So we need to do a call to shut down. Oh, sorry, escape. That works. Okay. Cool. My bad. It was not Q. Q is just a regular character. Okay, so what we want to do now, right, is capture the event for key down on enter. And if we have that, we're going to grab the, actually, this will be like input field. Right? And the current message just be a string. So whenever you press enter, then we'll capture the current message from text input current text, right? And then we actually need to send that message uh, to the Twitch processes. And I think what makes most sense here is that when we do the initial model, we don't actually do it there, but we do it here, right? I'm gonna move that in there. So this is not the initialization for Minty. This is the initialization for the Riot process that will run the Minty application, right? Cool. And here we want to actually find the process. So just like we have register in Riot, I forget if we have a function to see who is where. We have unregistered. Let's see. No, we don't. That's right. We would say then we would want Twitch, right, to register itself. So register, right, it will be Twitch. So Twitch is going to be Twitch. We could use the same name there. No, okay, I don't like that. I think we're just gonna use send by name, and every time we do name, we're gonna do send by name. Oh, we need to name like that to each other name. No, never mind. We're gonna hide that in here, right? We do need to do a registration internally, right? Twitch main proc, but that doesn't have to be exposed. So if we create an interface for Twitch, right, we won't have any of this stuff. All of that stuff is hidden from us, right? Even the register name. We need the string name here, the MLI, for it to be a Riot application. Open Riot. But otherwise, it should be that. However, we should have functions like send message, right? And then if you tell us what the channel is and what the message is, right? Then we will try to send that. So that will be a start. So when you do current message, right? Then we will do Twitch. Send message, right? Channel. And channel, I think we can do a little destruction here. No, sorry. Model, channel. And I think we'll need to update the input field, right? Because this is currently how do we clean it? How do we set the value here? Oh, I guess we could just do empty. After that, text input empty, right? So chatty is chatty dune. And we need all this stuff, but we also need Twitch. So that should fail. Chatty line 28. Channel. And then, yep, we don't have a send message function. That's fine. Twitch ML. So because we have a registered process here, then we know what the name is. So we can do send message, channel message, right? And this will be send by name, right? Name will be register name. And then the message we want to send is actually the send message of channel and message. Now this thing over here, right, will be we might need to split the reading and the writing to the socket. We'll see how we go about that. But right now we need to send this message, right? And the reason I'm saying that is that the receive operation, right, is blocking. So we have to declare some messages here. And one of them is going to be send message, right, of channel and message. One of 5. Right, we're not using the client ID at all. Not using the address. Really? Cool. So 171. This function is not being used right now because in the loop, right, we want to be able to we need a process that does the orchestration, right? Either it receives a message from you as a user or it receives a message from the socket. And then based on that, it does something on the actual connection, like a write. However, if we do receive here, then we will block, right? So we won't be able to read from the socket until you send something. And that's not what we want. We want to be able to get things from the socket ASAP. So I think I'm going to structure this. I'm going to split it a little bit. I'm going to make a protocol module here into each, essentially IRC, right? And we're going to put the capabilities, the replies, the command to string, parsing, all of these things that are related to the data itself that we move in and out, right? Whoa! We has been raided. I can't see much. It is so different to be on the receiving end of rating than on the other end. Thank you so much for the raid, Justin Musty. Welcome, raiders. I actually wanted to see the little animation or thing I put for the rating. I don't know if it worked well. But hello, everyone. We're doing OCaml here. We're writing OCaml. We are building a Twitch chat, right? That works from the terminal. All good, all good. How about yourself? How was your stream? Oof, nice. You get a URL to your website? Black and blue. Well, drop a link. We'll have a look. Shout out to Justin Musty, who just released a new version of the website. File live. Dope. Dropping a follow there. Nice. So, file live, what is this? Made for developers by developers. I need to sign up. Will I will I give you my credentials? Ooh, look at that, responsive. Oh, this is a SaaS. You got pricing here. I love this. It's a tiny SaaS. It's a tiny SaaS dev. Shing coming soon. Right? This is lovely. Coming soon. So you have a resumable uploader. Is this like an API? SaaS Pass. SaaS Pass. What does it say? Oh, cool. What does it say, Chad? Should we sign in and see what's up? All right, let's do this. Let's see what it does. Are you GDPR friendly? Oh no, that's my private email. Dashboard. Credentials. All right, so one thing it's not clear to me is like, what does this do? Converter between what? Like, do I give you a JPEG and you give me a PNG? Or do I give you an MP3 and you give me like an image of it? It's all right. It's all right. I respect any hackers. A resumable file uploader. So I want to say I get it because I understand what those words means. But I want to know like, is the use case that I have a large file and I need to upload it somewhere? So I first upload it to you and then you upload it somewhere? Or or is this like a library that I can use in my code? Because it sounds like an API, but I see some storage here. My bucket, like my S3 bucket or something like that. Yeah. All right. So I drop. Okay, there's SDKs. So dumb question, right? But I have to send your service the data so that your service can make sure it ends up in S3, right? Is that how it works? And I can use an SDK. Okay, we have some docs there. Ooh. Wait, so this is the library you're building? Yeah, Justin Musty. Nice. Cool. Modernize one branch. What I'm not understanding is if this does the work locally, or if I have to upload things to your service before. Sorry, you said that. Right. So this is a library then. But then the conversion, that would be the, like, I'm trying to understand what's your business here, right? Because a Python library, like, I can look at it and be like, okay, I'll just make my own, right? I'm not saying that I would, but what is the thing that you're offering as a service that is hard for me to replicate, so I have to pay you, or I choose to pay you? That's what I'm trying to understand. Data loss and parallel uploads. Um, I'm trying to understand. I don't understand how the library in itself, right, doing that. Hmm. Right. So then you're thinking of building something kind of like Sidekick, right? Not in terms of what this software does, but like the fact that there's an open source release of this thing, right? That you can use for a lot of stuff, right? But there's also a service or a business behind it, right? In their case, is mostly like a tier support, right, and features. But in your case, it will be like a service where if I want to convert things, then it goes through your service, you convert it, and upload it, right? Because what I'm trying to understand is like, if I have a file of 5 gigs, right, what makes your service more available than S3, for example, for me to send the data to you? In, oh, it's a Sidekick is a queuing library. It's a queue essentially, like background jobs for Ruby. Started as an open source project. It's still open source, mostly. Pretty popular, pretty well maintained as well. And then he has a lot of additions on top. I think it's a great model for like open source money making. All right. Thanks so much for that raid, and best of luck with FileLib. Yeah, yeah. If you have a demo, then let's do that. I understand. I'm not saying that you're doing queues. I was giving it as an abstract example of how to build something that is both open source but makes money. Ooh, reaction videos. All right, let me turn the music down. It's gonna pause. Nice. Cool. That ma- yeah, this makes perfect sense. Nice. Cool. Well, best of luck with that. If you ever want to make bindings for OCaml, so we can use file from OCaml, just let me know. We're gonna go back to a regular programming here. No worries, Justin. No worries. Thanks for the raid. And music goes back on. Why is this a live album? That's fine. Oh, this is the new stuff. No, I grew up listening to this album, the White Album. Ba-da-bam. No, 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 no problems with interruptions at all. I thought it was interesting that you're building a business around it, so I thought let's talk about it. That's good. I like that. Okay, so we're back here, right? We moved all of the protocol stuff to the other module here, and the formatter stopped working. There you go. So now we're left with sort of a connection handling thing, right? That reads some messages and knows how to connect and knows how to print some of the errors. I think there's more to get rid of here because we have all of these commands that are specific to, right? Inclusive of this ones over here, are specific to how we deal with this socket, right? Which is connected to a Twitch chat. So all of this stuff needs to happen on a socket that can write. This stuff is for writing. But we have the check all ACK because when we do a command, we also wait for reading. But we don't want more than one process reading from the same thing. We definitely don't want that. Okay, so I'm thinking we're gonna have two processes, right? One of them is gonna be the socket connected all the time. We get a ping, it sends a pong, right? Maybe we need to pull, like continuously send a message saying, hey, update, like read the socket, let's see if there's something new there, right? Because the problem is that if we have this loop, then that means this process, right, is sort of dead. We could handle replies, right? And if we get some reply, like a message, for example, here, and just to go to the IRC module, right, we will get a receive message reply, one of this. Then we can send that out, send that over, right, to a listener process saying, hey, here's a new message, right? So then this, the problem is getting information into this thing saying, hey, here's a new message for you to send. And we don't want to do this with some mutable data on the back. We want to do this by reading responses is fine. The problem is the receive. So we definitely want to be able to do a receive with timeouts here. So how would we do this in Erlang? Let's see. Erlang, or we can even say Elixir, IRC, Exerc, Bitwalker. A few things here happening, right? Let's look at the app. XIRC start, XIRC. We have a dynamic supervisor, so I guess that the clients are connections here. So how do we use this? Ha! Ha! Look who's here! I don't know if Ryan is on stream right now, but dude, we just found you. Definitely an Elixir nerd. Adding, okay, so this is using the event handler pattern. What is this formatting in Elixir? What the hell? Use parentheses. So it tries to connect, log on, join. Okay, message, this is lower level then. Much lower level. See, like we have a client process and that's fine. And then we're sending that things to that process. We have a handler process as well. And this is sort of the distinction we want to get. So let's see how this message function is implemented. Because my guess... wait. I think I know what the problem... Like, how they do it and why we can't right now. So if we go into client, message, it's just going to be a message. Sorry, message function there, like a gen server call, right? That's fine. So we just send that into the message, and this thing implements gen server somewhere. Yeah, use gen server. So that means we will have a handle call, right? Yeah. And then we have a handler and remove handler and connect and all the stuff, right? That you would expect from a gen server. So somewhere in here, I want to see when we get the actual messages, right, from the socket. Channels, nick command. So we're using transport, send. TCP error, TCP SSL, down. Handle data. Woo. Thanks for the follow, Justin. So, handle data. Where are we actually defining this? Is this a macro here? Use commands. We might want to look into that macro. So Elixir commands. Okay, we have a bunch of things. Do we have handle data here? Nope. Oh. Okay, so handle info. So in this case, right, we have a socket that is set to active mode. And should be active true somewhere. And maybe it's not here. Socket. How old is this code? Last year. Okay. Anyways, when we have a socket, right? Handle info somewhere. Handle data and info here. When you have a socket, right? Open in active mode on the beam, then you actually get the data from that socket as messages. If we can do that, then that means we can interleave messages read from the socket, right? With the messages that other processes send. And that is kind of ideal, right? Because we want to be able to send a message from Chatty and say, hey, just send that thing. Actually send the message, which will send the message to Twitch. See you. Happy holidays, Justin. Have a good one. And thanks for the rate. So I am thinking it might be time to actually abstract this into some generic socket, right? GenTCP. I don't know exactly what that's going to look like, but we would want a process, right? How can we do this, chat? We don't have timeouts for receive yet, right? So we could implement that. Or I guess a dumb way of doing this will be to say like we have a socket reader, right? And this is a process that if you give it a socket, it will just constantly read from that, right? And as soon as it reads something from there, it will send you a message saying data, right? So we can say like, I don't know what to call this, but let's say socket reader. And the only thing this does is call IO receive, right? And sorry, net receive here, this thing, in a loop. The main issue is that if we do that, then our request response cycle is broken, right? Broken as in split. Because right now we're doing this thing where we say, all right, I'm going to put a command there, right? And that's it. But maybe that's fine. Maybe we don't have to send you a command, wait for a response. Maybe we just need to say, here's the commands, I'm going to write them as fast as I can. Because responses are going to come back in different orders, right? And whatever response we get, right, we need to be dealt with anyways. And it may not be in response to a command we're sending. Okay, so let's sketch that for a second, right? We have a start link, right? And we will need to get a connection. That's the very minimum. And we'll just do a spawn, right? Our usual spawn link, right? Fun loop. And we'll get a connection there. And this already returns a PID. It never fails, right? But Starlink may do some other things, so we need to say that we're good. So we do loop connection, and we don't want to recreate a buffer every time. So we will look for our with capacity call, and we'll create a buffer, right? When we start. So when you loop, you have the buffer and you also have the connection, right? So we'll have a message D here, which is a TCP message, right? And you'll get a buffer. And essentially, we have a loop that will look like that, right? Where we would read responses, so we would do a large part of this. We'll read into our buffer from our connection. We won't do any processing at all, right? Whatever we read, we're not even going to turn it into a string, right? But as long as we can read correctly and we read something out of that, we're going to send you a message saying, hey, here's what we read from the socket. So we actually need not just a connection, but we need a receiver, right? And then we'll just do send, right, to the receiver, send message, our TCP message of our the buffer. But we don't want to send, So we want to actually, I think we might need to do data here and do a little split, right? First we'll get the recursion they're running, and we'll do data, and we'll do IO buffer. And I kind of want to create a new buffer here. So we have copy from going from the buff, which is our source, right, into a destination buffer. And this new buffer will just be the exact size that we read. So that's good with capacity len, right? So that way we put that in the message and we send it over, right? And then we can loop immediately and keep reading and keep sending messages. And you don't have to worry much about it. We worry about the buffering and everything else here. So this will be the first one, right? And okay, yes. So cool. I have a socket reader. Perfect. So we need this thing to always be up and running, right? Jesus, the alert is here. Leia, god damn it. You should see how nasty this thing got since I started cat seating here. It is just full of cat hair. I have no idea how to take it out. I'm gonna do a close up. This is gonna be gross. Ready? It's insane. But the materials are just perfect for each other. They just, god damn it. Nasty shit, I tell you. Sirtec. Okay. I usually get Loratadine. I think that's the name, Loratadine. But I think that's the name of the drug, not like a one brand. But I will look it up. Set TD scene. Cool. I will have a look. Set TD scene. So now that we have this thing, right, we can actually spin it up after we spin up the first process. Do like the reader, essentially, right? Socket reader. No, not even there. We can do it inside of the init. So once we connect and we know that we are connected, right? We can do socket reader, right? Start link. And we need the connection. And we need ourselves, because we are the ones that want to get the messages, right? So we can put the reader there. So that means at this point we should be receiving messages, right? So our loop is no longer a read responses loop, but rather a match receive loop. And when I see a match receive loop, I am happy. So here we will get a socket reader, right? TCP messages. And here we have a message, right? And that's a message we can parse. So we'll probably need to rewrite some of this parsing, because we no longer have our net receive functions, for example, right? We should not be calling that at all. We should be calling handle replies or handle data, TCP data, or something like that, right? I think that will be a good function to have here. So we get a message and we'll do handle TCP message, and we'll pass the message and the state, right? If we receive anything else right now, we're just gonna loop, that's fine. And we'll just define a function, handle TCP message, right? Message state. And here we can do something, some of the things we were doing before, right? So I don't think we'll have read responses anymore, because command is not going to do that anymore either. So I'll just move this code over, right? And essentially our carryover function, right? Feature, if you want to call it that, won't be able to be here anymore, because we cannot go into a loop where we read from the socket. We need to wait for the socket reader to tell us what's happening. So we would have to put this in the state. So the state would need to know, oh, we're in carryover state right now. We could also put this logic in the socket parser, right? Like we can turn the socket reader into something that you connect it to a socket, you give it a module for parsing things, and it will send you commands, right? And it will parse those commands and take care of that. And I kind of like that idea. So maybe we'll do just that. Uh, I'm going to move that code over here in our loop, right? Instead of just getting TCP data, maybe we will actually receive a parser module. So we have the receive. We maybe don't want to use the buffer like into a string directly. We need a function for parsing, so we have that there. Almost feels like we can do this. Receiver connection buffer. Buff. And if we have commands, right? We can send the receiver, right? So it's a little more specific to a use case, but that's okay. And instead of TCP message, the TCP command will reply with an IRC reply. So this could be an IRC command. And receive connection buffer. Cool. So now that should take care of reading the messages as fast as it can, right? Parsing all of them and then sending the messages as commands, as already parsed structures to us, which is great because when we get an IRC message, right? We actually get like if I can't destruct that there, can I? No. We get one of these types replies, one of this. And I love that because that is something we can definitely use to build a state machine here that keeps track of, for example, the current chat messages, right? Or the current users in a chat room. We don't have all that right now, but we want to be able still to receive messages and collect them. So when you say like, give me the messages, right, on a room, then we know what those are, right? And if you send a message, right, for writing, then we also get that and we can send that, put that into the socket. That's kind of good. So in this case, we don't need to do this anymore, right? We don't even need to do handle replies like that, right? We can just say if there's going to be an IRC reply, right? Then handle reply, singular. State. Get rid of that. This will be handle reply, singular, right? And we can now match on that. If it's a ping, then we'll do a pong, right? And then we loop. Pretty straightforward. And if it's anything else right now, we just loop state. Handle underscore handle. We don't need a reader. We don't need a receiver. No, we need we don't need the receive buffer. If we go to the state record, now we have a reader process, and this is just the PID. Cool. So that simplifies a lot our main loop, right? We just get the actual command already parsed. Love that. Now, when we say command, we don't need these functions anymore. We likely want to have them here, outside, at the top level, right? And the reason is that we will want them to be something like send by name, name, register name, right? And we will have, for example, authenticate, right? And then we'll do use unique pass, right? So in our loop, when we get a message, right, we would get some message like send message that we had before, right? And that will be channel message, right? And we'll get authenticate with nick and pass, right? And here we will just have tiny functions like handle send message, right? So channel message state and handle authenticate channel nick pass, right? No, nick pass state channel message and before we used to do this, right? And we'll have multiple commands. So now we just have one, really. Command. So we can translate that into command, state, right? And I think send pre message, that's the one. So we send that, and if we manage to send it okay, then we do loop state. What else do we have? We have join, very similarly, right? You could also argue that we want to do like, I don't know, something there, figure out what the right commands that we need to send is, right? If there are some. But we will have some other messages here that are not command driven. Ooh, so something's killing me here. And I think the last one we need to get rid of is this one. Pong, we are not going to do that externally. Send a message we already have. Yeah. And validate requirements. I think this is the last one. We really just want to send that, right? There is so much cat hair everywhere. Having a beard does not help right now. So tell me, what's happening? Why can't, okay, that is just the formatter not wanting to format things? Why are you being like this? Who hurt you? So if we go into Twitch MLI, right? Let's see what the inferred interface is. It's gonna be a nightmare of things. But if we get rid of everything that's auto-generated, then that's pretty nice. I don't like though that it's grabbing alphas and stuff for here. Like, why would you do that? I'm telling you exactly what types you need. It's send fucking message. You maybe you don't know where it is. Pong, where is Pong? Seriously, you don't know where Pong is. You don't. Okay. All right. Could be. What's wrong with this module? It compiles fine. Line 66. Ah, right. We just send one message at a time now. Which is okay. We just need to send twice here. My God, I am going to. My face itches so much. Perfect. So we don't have these functions anymore. And we just go straight into looping. So this will be our connection. What are you talking about? There's no join? Almost there, almost there. 54. Okay, so validate regs also has regs here. Line 63. Nice. So pass and cap rec, we never see that anymore. We don't really use a config anymore. We have to drive that from the outside. So Nick, it's gonna be passing to us. I don't see having a config at all being useful. Maybe for the URL and the default token, yes. Default capabilities. Cool. We don't need Nick. We don't need a pass either here. But when we do authentication, we might get a pass, right? From the default token. Okay, getting somewhere slowly. So it looks like the config is just a URL. So maybe instead of config, we just say you. Okay, that's fine. We can keep the config. Just format things for me, please. You see, so much to ask for that. Thank you. Cool. So now we can go into Twitch MLI, right? And get rid of that. And I think now the interface will be good. All right, not bad. So this is our API. When you start, you get a PID, and I think we might as well just. I don't think we can ask for that PID here, but we need for the application interface. At least pretty much everything else, right, has a reasonable API. Cool. So back to the config. We are never using the reader. That's fine. I think we don't really need it since we get called from the reader, right? And we are never using the config either, because we just use that when we boot. So it looks like our state is our connection. Are we even using the connection? Yes, we are. So let's do an exec. Hello world. And we press enter and nothing happens. Okay, so we've connected the socket. That's good. I think eventually we're gonna get a ping. But we probably want to do when we start, right? We're gonna do something like Twitch. Oh, come on, just give me the auto completion. I deserved it. I format, do the thing, kill the buffers, and then we're gonna go into chatty again, right? Twitch, perfect. And we'll say validate requirements, right? And we'll say Twitch authenticate, and the nickname is gonna be me. And then we want to Twitch join, right? My channel here. Okay, so that's doing something, right? It's pretty good. So hello, chat. We're gonna go into do Twitch ML and see what's happening with the loops, because we're definitely sending some things, but maybe we broke somewhere. What do we say? We say validate requirements, right? We authenticated correctly. But did we send a join? Yeah, we did say join. We need a single. Hello, chat. And we get the message here. So on the left, let's see if this works. We are writing from Chatty, the OCaml Riot Twitch chat. Woo! Yes! You saw that? Ha! Excited. Clip that. Cool. Oh my god. That worked. Perfect. So now that means we just need to build an internal state when we get messages, right? Because right now we're not doing shit with that. And we can do that like this. Trace, we're gonna do none. So I would like this thing to format my code. Format it. Loop. It did, okay. So whenever we get a receive message, right? We can destruct that. So now in our state, we're gonna do the dump thing, and we're gonna have hash table, right? With a channel to message list. I think that's okay to start with. So messages, right? T. And we want essentially string to string list. That's about that. So state, when we do that, we will do messages, and this is going to be hash table create, right? And we'll do, I don't know. Actually, we don't even need it to be that big. Cool. So when we do a receive private message, right? We're gonna grab the user, the channel, the message. So in our table, we're gonna do a message here, and the message is gonna be a tiny struct that will be like user string message string. Cool. So going back into private messages, right? We will literally grab the state and say like state is gonna be state with, oh wait, hash table is mutable, so we can do an ugly thing here. Hash table get, no, find. Actually, I would like to do I think fine. It will have to be find. Replace. Do we have a function to do an update? No, it would have to be a find. Okay, so messages, right? It's gonna be our channel. It's gonna be find optional for state messages, right? Channel, and we're gonna match with that, right? If it's none, if it's empty, then we will start with this. If we have something there, right? Some. Actually, we can just say message. Else, we will have a messages list, right? And we'll just put this one at the top. So now we can do hash table, add channel messages, or actually replace. State channels. Six nine. Where will we see here? Oh yeah, we need to drop some of those. $39 unused field. That is about to change. Wow, Nacho Ortega Estrada. Gracias por seguir, viejo. Gracias por el follow, loco. So if we do that, and this thing doesn't think, right? Doesn't know that we know, right? But we can ask. We can ask about new messages. So we actually would like to say let add handler, right? And then we get a PID. And so here we can just say, all right, I'm gonna send like an add handler PID. So we have a new message here, add handler. We need to add that to the type. So if we have a message as handler, we will just get a PID, and then we'll do loop state with handlers, right? PID state handlers. Pretty easy. So handlers is just gonna be a PT list, right? And I guess we could maybe get rid of a lot of this. And it's the client's job to keep track of the messages they care about. I actually kind of like that. So here we will just say list ether, right? Send PID, and then we'll just send a little message like this one. Self state handlers. Yep, and then we have to say Twitch. And that will be a public type, right? Public type message. The message, right? Of, we could even do that. That is something we want to leak, we want to expose, so you get Twitch messages, right? Like that. And then we'll do vol add handler, and then if you give us a PT, then we'll figure something out. We need to open Riot here. Cool. And then message, where is it? Message, Twitch, right? So we no longer care about this right now, if you're going to be handling that on your end. Actually, we will make it a separate message type, so we can extract it, right, on the other side. Cool. And then when we do send PID, right, we would actually do that. Message. We construct the message once. Actually, construct the entire thing once. And we just send it. Cool. And now line 99, we don't need channels anymore here. We just have a connection again, which is excellent. So type state. Right, we need the handlers. Handlers is going to be an empty list right now. Oof. So chatty, going back here, we will go from none to trace, just so we see things happening there, right? Chat, whatever you send is going to pop up here on the terminal. A little ugly right now, since it's debugged like trace logs, but soon, very soon, as an actual chat log. So we will do channels like that. And we need to go into the type and add the channels there. So channels is going to be really a string to each message. Hash table T. And oh, why don't you? It's like the LSP hates me. Seriously. I'm not very gentle with it, so I understand. Cool. So we validate, authenticate, join, right? And then we would have certain messages here, event custom, right? And in here we can match whatever we want. So we can say Twitch, whatever message is being sent to us that we care about, right? So we'll do model command. Nope. Yeah, look at this. Dylan Mulroy sent join. Not only did you join the chat, right? But you also send hello world. I don't see the hello world though. Oh shit, sorry. This is actually gonna send things. Give me 1 sec. We're gonna clean up those logs and then we can try it. So we wanna do with channels like that, and we'll do the code that I thought but didn't say out loud I wanted to keep find opt model channels message channel, right? We're gonna find the channel there. If we find nothing, then we'll just return a list with a message, right? If we have some messages, then we'll just append the message to the list of messages, right? And that will be our channel. And so actually messages will be like that. Oh, we don't need to do that because we are using a mutable data structure in OCaml, which is regularly normally a bad idea, but in this case we don't care much. Hash table update or replace model channels, right? And we'll do model channels, sorry, message channel, right? Messages. And this returns a unit, so we can get rid of that, put that there. Messages, what's your problem? Right, the problem is that this should be a list. Cool, so we're starting to collect messages now. I'm gonna disable the logging now. We're gonna go none here, so we'll see nothing when that happens. But now we'll be able to actually add into our view more things, right? Since we have a collection of all the messages, we can do let messages list reverse, right? Model message channel. Ooh. Do we have a current? Yeah, we have a current channel. Okay. So messages gonna be hash table find, right? Model channel. And then we'll do messages list reverse, right? Messages. And then for every one of the messages, right, we want to build a string. So let's do that. We'll do list map, right? Font message. We'll start with messages, like that. And format sprintf. And we'll do name, right? And a pipe like that. And then we'll put the message. Sounds easy enough, right? User message. Except that this needs to be a string concat, like that. And now that we have that list of strings, we can do string concat, right? And then put everything in a new line. And we can concatenate, I mean, this would be messages. And we can concatenate messages, right? With 2 new lines, right? And then a little prompt for us to write int. Whew. So I probably need to do open Twitch here. Boom, blew up. Makes sense. So I'm sending messages now from the chat. I think I'm gonna need to append to the chat messages my own, because I don't really see them here, right? So when I do that, invalid argument. Oh no, why? OCaml run param b. So if I press enter, hey Icy Code, thanks for the follow. to each message. And then when we send a message, we'll do kind of the same thing, right? And we need channel, which will be model channel. And then we'll do user, which I think is model user. Do we have user here? We don't. But we'll need that. Oh, right, these are equals. Hi, chat. How are you? Can anyone else see this? Oh, this is a chat, isn't it? Who am I chatting with? Money. Oh, come on, it didn't work. I thought it was gonna work. Damn. I wonder why. Oh, shoot, dummy me. So this needs to add a handler, right? And the handler needs to be self. Okay, so I think if you keep sending messages now, something will happen. I don't know. We'll see. Classic. It didn't work at all. Uh, okay, just bear with me for a second. Chatty, third's a charm. All right. So we're there. We got handler. We send it to the register name by name. And we add a handler and we loop. And we put the PID right there, right? And then eventually we will get a message like receive private message. Okay, so we are doing that. We are getting the custom message. Maybe we have borked the messages. Test. Logger, info, fun F. Custom message from. What in the hell? So the message is arriving there. So the message is there. And we call add message, right? And that returns a new model. You know what I think the problem is? We're in the wrong channel, folks. There you go. Something broke right there. If I send that, then I think I will find that the channel name has a hash. And our channel name here does not. Odd. That's kind of annoying. Because I wrote this whole thing under the assumption that we could keep, right, the channel names without the hash, right, and just do that. But it doesn't look like it's gonna be work that way. You can ask us anything you want. There's like a 50-50 chance that I will answer or rant. And maybe also a 2% chance on top that I won't see the message very quickly. What? Who is that? Is that Dylan Mulray on my terminal sending the first chat from Twitch to OCaml? Let's fucking go! Yeah, so there's a few things that need to be fixed, but they're mostly aesthetic, right? Like the username has a bunch of garbage in there, and we don't want all of that. Chat, do you see what this means? I can keep you on the screen now. I can see what you're saying. I don't have to look at my phone all the time. When I do this, I don't know if you see my face now, but every time I do that, it's just me looking at the phone. Like, all right, is chat doing okay? Oh, that is so nice. Oh. Y'all have no idea what kind of like stress relief I feel from this. Oh. Good. Cheers. And I mean, I can even write back, and you will see it, hopefully, eventually. Oh, come on! Did the chat break? Chat work. Well, maybe not. We chanted victory too early, but the POC works. All right. Yeah, I get messages. I just can't send them. So, yeah, maybe this will just be a reading kind of thing. You know what I mean? I think I do need to turn this into a supervisor so that we can do that. Okay, let's do that. That should be pretty straightforward. and then we'll pass in a config, and then we'll do supervisor, right? And then we do start link, and then we need a strategy, and that will be supervisor, and then we can do one for all. Actually, we'll just use the default because we haven't implemented many of them. We just want to pass in the child specs, right? And this is a list. And we want to do supervisor child spec, right? And that's a function. So here we'll do start link. So that's the function we use to start a child. And then the state, and the state will be config. So we'll just need to rename that to here, right? And if OCaml is happy with us, start link returns a child spec. Does return what? Oh, this is fine. We get a state, we return a PID. What are we missing here? Oh, sorry. The Twitch interface that we wrote has a garbage start function. And we want supervisor error. Cool. So we're going to do this thing. I think now it should work. If it doesn't work, then we broke something else. Can probably turn the login up for now. First, more like the only try that worked was the first one. Now it did work on the third try, but then none other worked. I wonder if it's going to be a multiple of 3 sort of thing. So what I think is happening and is that when we try to do all these things, right, we are still too early. And that's kind of what we want to do with init, but init is being too fast for us right now. Which sucks. So we'll need a better coordination tools for sure. Seriously? Okay, now that seems broken. Okay, yeah, definitely something broke here. Not a fan of this either. Oh, that is the build file. What is up with you? Am I getting? Maybe I got banned or something? Because I'm not even connecting to the socket. It's like taking ages. Let's see if we can telnet, right? Eric chat Twitch TV 6667. Hello world. So that worked. But why are we resolving that other address? Okay, no. There's many addresses. Should be fine. We'll get a config. I I don't know what's happening. Is it this the problem? Okay, so the supervisors are broken. Is that what you're saying? So Starlink, we passing the child specs. But why isn't the supervisor working? Okay, fine. I'll look into the supervisor some other day. And if we remove this, match with. And James. Hmm. Curious. So we're getting some of these logs for sure, right? Let's see. Sending message. Because I don't know if I'm actually getting anywhere. Whoa, we are getting very much there, but we're not writing to the socket. Handles and message. We call command. Yeah, we're not getting here. Server states, all this stuff, but we managed to join, right? So how? Print command. I think. Whoa, we definitely put the message there, but notice how we don't see the message sent, right? And I think there's just a problem with the command function. I don't see the sending bytes either. I see them here for sure. Hmm. So I'm wondering if now that we have someone joined called Hola Hola Wedding Boys. Cool. Some Frank Wang is also here. So I'm wondering if now that we have these calls, right, they're not behaving as nicely. Hello there, Glitch Bite. Why can't I see this line? Okay, something died already there. Good point. I think I forgot something about Minty. I wonder if we're just overriding some of the outputs here. So we'll write that many bytes and then wrote len. Hello world. So that actually sent the bytes. I don't know if you see anything. I don't see my chat updating here. A list. Barracuda. Fambiag. The great crew. The great crew is online, folks. Welcome. All right. So we seem to be stuck, right? Here. I mean, in this case, we do say we will write this much, and I think we even say that we wrote hello world. Yeah, we wrote that many bytes. But either we're not, I don't get it. I don't understand why. We went all the way down to writing to the socket and we wrote the damn data there, right? So what is different? It is probably something dumb. Just can't see it. All right, let's try again. No logs, right? Hello, chat. We have seen this go all through, right? From here to here. That didn't work, nearly as expected. To here, to actually sending that message, right? To receiving the message, to handling the message, right? And routing, we're gonna be sending this thing, right? And then actually calling send proof message and writing that command, right? To the socket. And we've seen that we write the damn socket there. We are the youth gone wild. Okay, so I think we need to do some more debugging. We're gonna write more messages here that we're gonna get out, right, of the Twitch process. So we're gonna do login successful. We're gonna send a message for that, right? Just say login successful, like. So on the other side, right, on the chatty app, we'll get a message custom and we'll say, all right, logging successful. Just that, right? So we can add a message, right, to our chat. And the message will go to the model and it will just say like logged in. We probably can so this is not our type, so that kind of sucks. But we can add a system message saying logged in. And then in here, we will just get a message. And a message can be a system message of string. Hey, Buttercup, how's it going? Thanks for the follow. Yep, we're doing some OCaml here. I believe I just added that to the interface. Login successful. And I have a typo there, of course. There you go. So the message will be a channel, and the channel will have the same channels we have. So model channel, right? And then the message, the body is going to be system logged in. Cool. Channel. So that will add the channel to the right spot. I believe 36. That's fine. We want to do let message is going to be channel, same thing. But the body is going to be Twitch. And we're going to put a message there. Cool. Twitch. And then which you should actually have. Which. Just come. Oh, if I could only type, right? There you go. Cool. So now when we do this thing, we want to print messages depending, right, on who they're from. So we'll do match message with, right, message body actually. If it's a system message, right, then we get the message here. And then we'll just print it somehow. And if we get a Twitch message, then we're going to print it differently. And this will be system. We can do some styling later, right? But right now it will just be message. And yeah, we can do that. Body Twitch. Whoa, what did you do to me? Hello world. How could it be? This was working, and then without us changing absolutely nothing, it just stopped working. And we have done all the debuggings that we can possibly imagine, all the way down to, are we writing this thing to the socket? And if so, then how much have we actually written? And we see like, oh yeah, these 33 bytes that you said you were gonna send, we wrote those. when we try to type things on the chat, that works, so we can read. It's pretty terrible. We're gonna do least nth one. Oh yeah, this is terrible. It's the other way around. Pattern and then width. Good, but we can do better. There you go. That's the stuff. Hello there. That should be me, but it does not send now. It doesn't send things. It does not write to them. I don't know why. It is possible though that we have a bug, right? In the way that we are maybe we just need to use the buff writer here. Nothing coming. So let's say we do that. Let's say we have a socket and we do a writer, IO. No, I think we need to do a socket to writer state con, and then we can do IO write all, right? Writer data. One three five. Okay, we're missing in a file. Do not know what that would mean here. So messages coming in are fine still. I just want to replace the first one. Drop one. Nice. Isn't this what we expected? No. So, for y'all just joining here, we are building a Twitch chat with OCaml, right, on the terminal, and this is using Riot, the multi-core scheduler, and it's using Meaty for building the actual chat UI, right? And we ended up building a TCP, IRC protocol support to be able to talk to Twitch. And here we are. So my guess is that the net receive maybe it's a little too aggressive. So what happens if I actually sleep it for like half a second? No. What happens if I don't start it? Brock. Okay, I'm gonna go with the assumption that the IO is working, but we're sending the wrong thing. So we send a message that makes no sense, right? And I think it is not that crazy considering that we are sending our current channel, right? Fuck, that's the problem, isn't it? And when we send the channel, send message, that goes into here, right? And it gets turned into a send private message like this, right? And this is in the command call. And this thing calls command to string. And guess what the fuck this will do, right? When it sees a channel, it will add a hash. Fuck this thing. No, it should work. Come on. It works. There we go. Ladies and gents, it's a working again. And we had zero way of knowing because the server just did not complain about it at all. All right, so if you chat now, then it will pop up in my screen and I'll be able to chat with you through the terminal, which is kind of cool. All right, so we're gonna git ignore that, and we're gonna say grab everything except that token, and we're gonna do boot first working version. Cool. We're gonna push everything to that repo. Yeah, the TUI is not perfect yet. And we have a repo here called Chatty, where we just added the code for this stuff. Whew. Anyone here? Oh my god, I broke the whole thing. Why did he die though? I think now we can do what we wanted to do with the supervisor, right? Let's Starlink, config, and then we'll do supervisor, Starlink, child specs, and then supervisor, child spec, Starlink config, and then that. So at least the connection should like come back up if something happens. Hi. Why? Why do you do this? Why do you stop working mysteriously? So that works, but the supervisor kills it. I don't like that. Hmm. Oh, oh, oh. Ay, ay. So, not a big deal. Just, again, le moi being dummy. So, we actually want to register our PID, right? Here. Format, run. And that should pretty much run. But, of course, now we registered too slow. So we run into the orchestration problem we had before. LP, no, that. Hello there. That's your send messages. Perfect. So we can remove the tracing again. All right. Oh. Hi, chat. And we can even join other channels. Let's see who's online. Whoa. Nope. No one's online? Musicians. Let's see. Who's streaming here? Real stuff. All right, there's a bunch of viewers here. Let's see what happens when we join that one. What's the name of this one? It's PPY. All right. Hello, chat. Does not seem like we managed to join that chat though. Is it PPY? Yeah. PPY. Oh wait, we do join here and we should do PPY. Hello, chat. It doesn't look like. Oh, this is a follower chats only. Really? All right, fine. We can follow you. What? We just follow you, and that didn't work? Nothing against you. Just follow to send the chat. Damn. This is where Twitch streamers going to die. There's nobody viewing anything. 1.3, 10 viewers. Let's go here. And we want to join there. And then channels. Hello. Woo, cool. We are chatting to you from another stream where we build a terminal Twitch chat using their oh great. We definitely need layouting algorithms here. Chatbot using their TCP IRC server. That didn't work, did it? Woo, cool. Let's see if we can send smaller messages. No, it definitely, yeah, something happened there. We are connecting from a terminal chat Twitch client. that we are building on another stream right now. It's pretty cool. Written in OCaml. Anyway, sorry to barge in like this. Have a great stream. Whew. I have become a chatbot. It's pretty fun, isn't it? Okay, so that was cool. It's not even close to done. There's so many kinds of things we want to build here, right? But the infra is in place for us to do that. So yeah, we can now do this. I wonder what would a nice UI TUI, right? TUI, TUI for Twitch would be like. Hey, Olympic Nautic, what? Gizonics, Xonics. Thanks for the follow. Whew. I am pretty tired though. So let's do that. Let's just do a little recording of this thing so we can drop it on the Twitterverse. QuickTime. We're gonna do screen recording. We don't need all of that. We can do much smaller. That's good enough. Hello, chat. How are you? Oh my god, we are so good. Okay. Bye. We can do export as, I guess 720p is fine. So chatting. No, I don't want to do. Do I want to do mob? Maybe not. Damn, 10 megabytes. And we has done it. OCaml can do everything. Can it? Here's chatty. multi-core ready, multi-core friendly. Twitch. Okay, well, here's Shady. We built a TCP ERC um, client to the Twitch IRC server and tried successfully on stream. The Michigan is here. We even went to another stream and connected there, and where became a total bot. This was fun. We built some cool things along the way. And dev learnings, some of which may become packages soon. On top of Riot, and then we put Minty TUI on top of it using let's be no what's the name? What's the nickname? Fuck. Ekander, right? Ekander. Using Ekander's new text input component. Shrink. And then try to successfully on tree. On top. Cool. All right, folks. I think we're gonna go raid somebody, and I'm gonna go watch TV or something else. We has done good. We have some tiny little patches for a couple of packages, right? Like Minty has some things that we fixed. Riot, I think we fixed something here, didn't we? Yeah. Oh yeah, we definitely did. We avoid. We reduced the logging on Socksan because we were logging everything that we put into a socket, and that's a bad idea, right? Well, I mean, it's because we had like clear sockets, so you could see exactly what was happening there. We almost leaked credentials that way. Oh my god, crazy. Can I close that? Just quick check on all the PRs and stuff and see if everything's good. Circuit pool, no more issues. Minty, no more issues either. Did anybody comment here? 3 comments, no. That's good. What about the PRs to OPAM? They're still open a few. I don't get why Riot 7 is failing like this. I'm pretty sure it's still gonna be the same environments, maybe. Yeah. Ay, ay, ay. Oh yeah, let's check if I actually got. No, come on, seriously. But maybe the last thing we could check. Come on, line tutorial, bit strings, access tokens. Nope. We could check in Cloudflare the status of OpenAI of OCaml.ai. Yes! Boom! It is set up. So that means we can do this on stream. Excellent. That means we can go to the Chat GPT, right? No, Chat GPT, the custom version, right? And we can make it public. No, with a verified domain. And if I'm not mistaken, we should be able to go to chat.openai, ocaml.ai. I don't know how to do this. So we do the custom thingy. That's fine. That's for verification. What does this mean? Does that mean that we can go here and it will take us to chat.ocaml.ai? Or we need to set DNSs? Chat. I don't get it. OpenAI custom GPT custom domain. Introducing GPTs. Domain. They don't have that. Maybe in creating a GPT they have something. Domain. Verify. Maybe we can ask ChatGPT. How do I set up a custom domain for my custom GPT? I am using the custom GPTs from OpenAI. Just need my own domain. Okay, come on. Just that's not what I want. I don't want to write any code. Can I use the verify website? Uh, well, I'm confused. I don't really know then what the hell does the custom GPT option do here. Edit GPT, right? And if I go to website, So that's everything I did, and there's no conclusion. Are you kidding me? That's for that? Oh my god. So I'm gonna have to add page rules or some other crap. Let's try that. So rules. We have a page rule already, right? Or we had it one at least. Okay. So chat, and we wanna do forward URL. And let's do temporary so people. Now, Leia, what are you doing? You okay? Coming back to life. So custom GPT, save and deploy. There is no room here, Leia. You are falling out of the table. So much allergies, but I also like you so much. So chat.ocaml AI. Yeah, she's great. Her name is Leia. I'm cat sitting actually for my best friend. So taking care of Leia is just my day to day. Can probably do that. Chat or camel.ai. I don't want to pay for more crap. So I guess one day this will work. It does seem like a missed opportunity for OpenAI not to sell you the custom domains, but let's not give them more ideas. Ah. Okay, so maybe in the morning this will be fine. But that was that. We has done it. We've been building a lot of things lately. We built an actor runtime called Riot, with Crazy Fast IO, a TUI component, a terminal user interface framework called Minty, with a bunch of components that some people are contributing to, which is kind of fun. Some nice color transformations that we're not using in this application right now, but we could definitely use. We build a CA store to be able to very quickly and portably do TLS, right? And an HP client that actually uses the CA store to get TLS support, which is pretty nice. And we did all that so that we could start building a TUI chat client. Because in a thread somewhere ages ago, I promised Thomas that I would have a look at that. And we started. And today we built some more things here, right? We built a TCP IRC client part. We built a TUI. We got some tests started. Yes, it's good. Building in OCaml is good. So why don't we go raid somebody? This is not going to be ready any second now. All right. No one I follow online. PP1 year end. Playing Valhalla. Oh, this is the person we were in the chat for. All right. Dropping a follow here. Folks. Raid. Where the hell is the chat? Oh, it's down here. Raid. And their name are Maweeksy. That looks like code, Python. All right.